Ladies and gentlemen, good afternoon. Thank you very much for being here. My name is Laurent Haug. I will be the host of this exceptional event. We are here to celebrate a proposal that was made 20 years ago by Tim Berners-Lee, and this paper is considered to be the starting point of the history of the World Wide Web. This document received a quite laconic and interesting answer from Tim's boss, Mike Sandel, who said it's vague but exciting. I think you know the rest of the story. So the event is going to consist into two panels. First, one about the history of the web, and we are lucky enough to have most of the people who participated in this historic invention. Then we'll have a short break. Tim will do a keynote giving us his vision about this history and the future of the web. Then we will have another panel. And I have to also say a few words in French because we are live on LCI. So I'm going to switch to French for 1 second. I'm sorry if you don't understand French. Bonjour mesdames et messieurs, bienvenue à la célébration des 20 ans du web. I know Tim understands French, actually. 10 years in Geneva. That's great. Nous allons aujourd'hui parler de l'histoire du web avec 4 des personnes qui ont participé à cette grande aventure. Ensuite, Tim fera un keynote et nous aurons un panel sur le futur du web, pardon. Et les débats seront en anglais, donc j'espère que vous pourrez suivre. Back to English, to welcome you to the CERN, to the globe, to this amazing building. We have the Director General of the CERN, who's going to give us a short introduction. Please help me welcome Professor Rolf Heuer.
Thank you. So, thank you very much. Good afternoon, everybody. Bonjour tout le monde qui est connecté. First of all, I'd like to wish you a very warm welcome, not only because it's warm because of the sun, but really a very warm welcome to CERN. And I also wish you a lively and stimulating afternoon of discussion about the past, the present, and the future of the World Wide Web. Now, when I first learned that Tim Berners-Lee wished to celebrate the 20th anniversary of his invention here at CERN, I was, of course, delighted. As you all know, Tim was working here when he wrote this paper, and you just got the quote of the vague but exciting, which was written as a phrase on top of his proposal for an information management system, and thereby, this I would say was signing the web into existence. Now, I can tell you CERN is very proud to be the home of the web. CERN is a place where smart and highly motivated people come together to expand our understanding of the universe which we inhabit. It's a place where nothing is a problem, well, nearly nothing, okay? But it's rather a puzzle, and I think we have a strong track record of solving those puzzles. So, back in 1989, CERN was the host of some of the largest, at that time already, and most geographically distributed scientific collaborations. And these were numbering up to a maximum of 700 scientists in one case. Today we have more than 2,000 or more than 2,500 in some of the experiments. Now, at that time it was a place where a computer on every desk was already the norm. Computer networking had been a fact of life for over a decade already at that time. And where we had a culture of sharing and openness. In short, it was the kind of place that was just waiting for the intellectual spark needed to ignite what would become the World Wide Web. In Tim's own words, CERN was a lab which pushes back the boundaries of technology as a matter of course in every aspect of its daily work. It still is. The puzzle faced by Tim was how to create a system from the ingredients around him that would provide a new way of CERN's diverse community to manage information. And that's the key word. We needed at that time to manage information, to get it quickly, reliably, everywhere in the world. That was the point. And what was the solution? Well, the web. Actually, at that time already, I was working here, and I remember the early days of the web. Like many others in the experiments, I just took it for granted. Well, we physicists are like this. We take what we get. And we took it, and we did not foresee the incredible phenomenon it has become today. Thankfully, Tim did, and his boss, Mike Sandel, was a good enough judge of character to recognize the potential. I'm pleased that CERN provided the canvas for Tim Berners-Lee's invention, and I'm honored that Tim has chosen to be here today. But this is Tim's day, and your day. So Tim, I wish you a very warm welcome back to CERN. I hope you still recognize the place, maybe not this one, but the rest, after all these years. And I hope that you enjoy, together with everybody else, this afternoon of reminiscence and anticipation. Well, very welcome, very warmly welcome. Thank you.
Thank you very much. Thank you. I will do something about the slides. So we are going to speak now about the history of the invention of the web, about the first 20 years. And our first speaker is actually one of the main reasons that everybody's here with us today. He joined CERN in 1971. He's a honorary member since 2002. He works today on volunteer computing and virtualization technologies. And from 1983, he coordinated the introduction of internet protocols at CERN. And once Tim signed a book for him, and he wrote that Ben was a mentor for him about internet, remote procedure calls, and all sorts of things. Please help me welcome Ben Siegel.
Tremendous honor and pleasure to be. Is this working? Tremendous honor and pleasure to be here for this wonderful day. Welcome, Tim, back to the old hunting ground. And there's the picture of the diagram I still don't understand. The young man, about 93, I think, there, with the keen look. And the theme of this talk is what Tim said to me around 89. People just need to agree on a few simple things. That's why we're here today. I remember saying to him at the time, Tim, that they'll never agree on those things. It's not in their interest. There's too many different companies. There's too many different lobbies and so on and so forth. And the miracle is that they did. They agreed on just enough to make this work. We're going to go far, far back in time. 6 generations of IT technology is 20 years. I'm going to talk about the 10 years or so before that time. So we're talking 10 generations. It's only 1 generation of humans, but it's 10 generations of technology. And believe me, things were really different. The world was a zoo. I believe that it would be much easier to create the web today than it was then. Do you agree, Tim? Yes. Right. So, why was it such a zoo? Well, in the computing standards, there were so many companies. There's a list of some of them. They all had different operating systems. They didn't like to communicate together. They had different networking systems. But some hopeful things started around that time. And there was something called the Unix operating system, which had appeared and started to come out of the research environment, and with great promise for a lab like CERN. Networks, the same. Everyone had their own. CERN had at least 2 homemade networks, Omnet, which was a very fine network, and CERNnet. These were homemade networks which didn't know anything about IP, even though they could have done. But ARPANET was very little known. ARPANET was American. We were European. There was an international committee run by the International Standards Organization trying to standardize protocols, and it worked very much top-down and very slowly, and it was confusing things. But again, the hopeful thing happened around 1980. Something called TCP/IP appeared and was noticed by a few people. but they were opposed. These protocols were opposed by the powers that were, the European PTTs, European industry, and they were largely opposed also at CERN. So to make the web possible, the bare essentials had to be in place, and they were. And who had done the work for that? Well, some of them are here today. Unix came in the door about 1980, and we had a Unix guru, Dietrich Wiegand. He's sitting there. You didn't have to ask Dietrich an easy question or he'd get quite upset. You have to ask him a hard question, then he would answer to you. Gordon Lee worked with him. I hope Gordon is here. Les Robertson managed that introduction, and David Williams, who was the division leader, did support the introduction of Unix here. Les couldn't be here today, I'm very sorry. But what came in with Unix was email. Yes, we hardly had email before 1980. The Usenet discussion groups, which most of you haven't heard of, but which were in fact the medium by which Tim could put out his code on the net because the web didn't exist. And C programming in a portable language, which had been a curiosity before then, and which was not encouraged at CERN before this time. In 1981, we had a very inspiring project called the Workstation Project, based on the Apollo computer, led by Ian Willers with René Brun, who is definitely here, sitting there, David Foster, who when he came in the door was a young hardware enthusiast, became a compiler writer, and that launched the whole field of distributed computing and clusters of PCs, which now rule the world, here and elsewhere. In 1983, finally, we got TCP/IP into the door. It actually had come in the Unix machines that we had, in some of them, and I, under the protection of Les Robertson, brought those protocols into the lab, and we connected up the zoo of machines inside the lab, and they were then picked up at the SPS for the control system by Pier Giorgio Innocenti, who I just met, and Jack Altabé, who I don't think is here, and Paul Anderson, who did a lot of work, and Olivier Martin, who is not here either. These are the people, some of the people who worked to get the internet protocols, that's what TCP/IP is, in the door here and working. Finally, there was a little private project going on in '89 by Emilio Pagiola, who had brought the next machine into the lab, again, unauthorized, unwanted, which was the final element that Tim would use to prototype the web. Remember, it was a very hard environment for people working on these new technologies because we were at the bottom of the heap. This is the political order inside CERN. It still is like this. On the top is physics, accelerators, and the rest. Inside the rest is computing. There was an order in computing. The big mainframes. We had 25 million francs worth of gear sitting on the floor, about the power of what's in your telephone today, less than your iPhone. And the rest. Oh, there was big hardware, the tape robots. There are still tape robots in the lab. They're still expensive. And the rest, the desktops, the clusters, the networking. Inside the networking, there was a hierarchy. The external networking, which was part of the zoo. The internal networking. Ethernet had come in the door in '83. I remember the thick yellow cable coming in. CERNet was in. And right at the bottom of the heap was TCP/IP, which was special. And it was actually illegal until 1989 and of '88 to make an external connection from this lab with TCP/IP for all sorts of political reasons. There's a quotation, September 1987, the TCP/IP networking is not a supported service. It was connecting everything together, including the new supercomputers, the Cray, etc., but it was not a supported service. So, the paradox then of the web at CERN is that this very, very hard problem to connect heterogeneous information on heterogeneous computers, on heterogeneous networks all over the world, a very, very hard problem, was solved by a small, non-official, open approach by a team with no resources, or practically none. Yes, the web was created at CERN from the weakest part and using the underground. it was probably, in retrospect, a good thing. It had to be kept simple. It had to use outside resources, which we'll hear about. And so I think it probably went faster in the end. It probably could have got off to an earlier start if the internet could have been opened up before that. But when it happened fast. And the missing ingredient, or the vital ingredient, when people say, was it an accident? It was an accident, except that the vital ingredient was Tim Berners-Lee, and he was here. He was here, and CERN was tolerating what he was doing. They didn't close it down. And he had a wonderful manager, Mike Sandel, who encouraged him. He had vision, he had persistence, but he was also a great implementer. You see, lots of people who've got vision and persistence, they can't program. Or they can't program on the zoo of machines, which was there, which had to be done. Tim could do the design, he could make the choices, and he had the tools, and he understood the tools, and he built before this, in the 4 or 5 years before this, or 3 or 4 years before this, he built a remote procedure call system, which was implanted on all sorts of machines at CERN, from the biggest mainframes down to embedded systems in chemic crates. So he could work in this environment with his hands. Finally, my last slide is the credit. The message for management. 2 managers who had vision, political skill, and who knew how to make space for innovation in a conservative environment. To Mike Sandel and to Les Robertson. Thank you.
Thank you, Ben. I keep the microphone. You can have a seat, please. I will leave that up because the rotating slides are a bit distracting. Joining Ben now, he was a co-parent at CERN. A co-parent is a contribution of the French army to the world. They allow you to skip army and actually do something more useful. He's one of the first programmers with Nicolas Pello to work with Tim. He wrote the lib www, a code library to build browsers and servers, and he is the founder of the first ever web business. Please help me welcome Jean-François Groff.
Thanks, Laurent. Thank you. It's quite amazing to be back in time 20 years. It certainly makes me feel very old. Being here with, of course, the team that created the World Wide Web, well, they're all on stage. And I'm very thankful to, in particular, Ben Siegel, who introduced me to Tim when I just arrived at CERN in the middle of winter in a snowstorm. And it was at Christmas time, 1990, actually, that Tim had transformed his vision on paper to working software, which was running on this beautiful Next box back there. And the Next machine was a creation of Steve Jobs. So you see that great minds always connect through space and time. So thanks to the tool set that was on this machine, which was very advanced for its day, and thanks to the introduction of internet at CERN, and thanks to his background and brilliance, then Tim could write the whole software in just 2 months. And this software was not just a browser, it was also an editor. Because we technologists, we thought that it was really awkward to ask of people to type a URL starting with http://, and that they shouldn't see a markup language with various angle brackets and tags. And we were very surprised that people were willing to write HTML pages by hand, by themselves, without tools. So we wanted to give them the tools so they could just write whatever they wanted, just like a word processor, and build links. The key invention, it's a word processor plus hyperlinks over the network. But people didn't want that. So what happened is all the early tools for the web were one way. You could read, but you could not write. This changed with the second wave of the web in the early 2000s with the Web 2.0 movement. It's still not, as fluid as it was on the Next. I hope we'll be able to see a demo later. But it's amazing how technology sometimes takes an unexpected path to success. But what a great success. So to come back to these days of the computer zoo, the problem, of course, after this brilliant software was working on the next machines, and we were actually writing the documentation of the software with the World Wide Web itself. We were just typing in while we were writing the system. But nobody else could see what it was. And one of my early tasks at CERN was to install a hack on Tim's machine so that people from anywhere in the world could connect to that machine and instantly be in a web browser. It was not a graphical web browser, it was pure text. It was based on the Line browser written by Nicola Pello. But then suddenly you said telnet info.cern.ch, and you were in the web, and you read the documentation about the web. What is the project? You could not click a link, of course it was text, but next to the hyperlinks we put little square brackets with a reference number just like in a book. So you typed 2, enter, and it would follow the second link. This is the way most people in the early days experienced the World Wide Web. This is a documentation system which is text only, it's networked, and it's hyperlinked. But of course they didn't know that we had this read-write editor. I think it explains a lot of what happened later, so it's all my fault. So besides, I then helped Tim. I had a background in C programming. I had translated the Kernighan and Ritchie textbook about C, and I helped Tim write the core software library that let people build browsers and servers and connections to databases for all kinds of computer systems. So one of the very early ones was the CERN phone book, which was running on the big IBM 20 million mainframes. You know, it was used for the phone book. And we connected to the phone book with the help of Bernd Pollermann, who's not here, unfortunately. So that was amazing. And yeah, so we developed that library. It could run on IBM, on DEC, on PC, on Mac, on Unix. And basically, we gave it away to the world because we didn't have the resources here. We wanted to hire a few students to write browsers for the Mac and for X Window and for the PC, but we couldn't. So we said, okay, it's free software. Well, actually, it wasn't really, but a few years later, CERN did the right thing, the political decision to make it officially free. And you can go ahead and write whatever you want. And we had an explosion of browsers, and out of all these initiatives around the world, one of them was extremely successful, and it was called Mosaic. And Mosaic then begot Netscape and Internet Explorer through another path. So there's a legacy of all this early code written at CERN in Office 5131007 in all the browsers you use today. No, then they replaced all the code because it was junk. That's all I had to say.
Thank you very much, Jean-François. I mean, the web could only have been invented in a place where offices have 7 numbers to identify them. We have a bit of shuffling to do with the computers. Our next speaker has been a staff member at CERN from 1974 to 2007. He was last the head of external communication. He worked on developing and disseminating the web and the consortium from 1990 to 1996. He's the founder of the International Web Conferences series, and he worked with the European Commission on several web projects, among other the Web for School. He is the second user of the web, or co-conspirator of Tim. Please welcome Robert Caillot.
Yeah, great indeed to see you all here, and very moving occasion actually to remember this. 20 years ago, I mean, any youngster who is 20 today has never known a time without the web. This is just unbelievable. I mean, to me, it's just like yesterday, you know. And if we go even a little bit further back and think, you know, well, who's the inventor of the web? Well, he sits there. Fine. Who invented the computer? Was it John von Neumann? That's what the Americans think. Was it Alan Turing? Was it Konrad Zuse? No, it was Charles Babbage. And I think somebody else before, I think it was Jean-François, or maybe Ben, who said, you know, you have these people who have the vision, but can't sort of do it. So before we had the web, we had a big vision. Xanadu that came out of a guy called Ted Nelson. Now, Ted Nelson was a writer, so he understood how to write stuff and how to explain things, but he didn't know how to write software, unfortunately. And I have a photo here, one of the rare photos. I'm in the middle. You might as well forget about me. But on the left-hand side, you see the inventor of the web. And on the right-hand side, you see the inventor of the idea of Xanadu, the idea of global hypertext, Ted Nelson. Now, let me become an anthropologist for a second here and cut myself out of this picture. The picture was taken by Håkon Lie. Håkon Lie is unfortunately not with us. And let me cut myself out and get these two people, Tim on the left and Ted on the right, so that you can see how they really love each other, right? And anybody who has read Man Watching will note that both of them take exactly symmetrical poses. They're about to bite each other's nose off, right? Yet I think both of them... Sorry? Yeah, you were 6 feet apart. It was Ted's 60th birthday, and it was in Japan. But it just shows you that some of these things have actually quite some prehistory, and then sometime, somewhere, with some person, it all clicks together, and from then on, it explodes. It's sort of like an hourglass. Things come together in one singularity, and then they explode from there. There are more interesting things that happened in the early days. There was one time where when you had just made the first bits of software, and we had submitted a paper to the Hypertext conference. But the Hypertext conference thought, well, what good is this? This is such a simple system. This is such a lousy hypertext. And why try to do anything over a network? You can do any hypertext studies on a single computer. So the paper was refused, but we were allowed to hold a demonstration. And so I went all the way to San Antonio a couple of days before Tim, because Tim was very, very tired and exhausted. And I set up a demonstration, and I made this photograph on the beginning of December. It was the 17th of December, 91. It was just a few days after the first server in the United States had come up. And so this is a younger Tim with a number of probably not very well understanding people around him watching what was going on. The panel on that you see on the left-hand side of the next computer, and by the way, it was a similar machine, but it wasn't that machine. The panel that you see on the left was actually used in a court case, because later than this, somebody claimed to have invented access to databases, but that panel already shows access to databases. And then, of course, as we heard a couple of times before, how could we do this? We could do it because we had Mike Sendel, who unfortunately has left us now almost exactly 10 years ago. Mike was the boss who didn't say no. He was the person, as Ben also highlighted, who saw that this was good and should go on, even if it had to go on in a corner. He was also the person who wrote vague but exciting on the paper, but he understood, and I think Mike was crucial in getting it going. Mike, however, was very self-effacing, so self-effacing and so much in the background, British gentleman type of person, that I had great trouble finding this photograph, and I had to color it by hand because it was black and white. Now, what about my role in this? I ran around like mad trying to convince not just Mike that it should go on, but the rest of management, and also trying to get the resources together, going to the European Commission. And one other thing that I worked on for 6 frustrating months with the legal service was a paper for placing the entire technology of the World Wide Web into the public domain. And this paper, of which you see here only the top part, what was crucial also, because it said, go ahead, guys, you can pick this up and you can do with it what you like, provided you just mention CERN and provided you stick a little bit together. So that was a very, very crucial paper. And another thing that I did at the same time, and I remember you there, Tim, telling me, well, do you really think you have time to waste on this? And I thought, yes, I do, because in the future, people will indeed write PhD thesis on stuff done with the web. And so I got the international conference series off the ground, and when the first one in '94 was over, I slept for 48 hours without waking up because we were all so tired. 1994 was a very, very busy year, as you remember very well. Lots of things happened. The conference was only one, and I can tell you that my wife also, she's sitting there, suffered from all this. The series is still going. The next one is in April. And so the role of CERN actually, if you like, is of course the founding proposal, giving Tim the opportunity to actually let him do it. The first software, of course, and then after that, this putting into the public domain, very, very crucial, I think. The first conferences, and then also in '94, we had the real problem of financing the Large Hadron Collider, and at the end of the year, we decided that there was no way that CERN was going to continue doing development on the web, and we transported the whole thing out of CERN into the consortium, run by INRIA in France and Europe, and by MIT in the United States. And that leads me to my last slide, where I have to mention at least the person of Jean-François Abramatic, who was head of development at INRIA and who devoted 2 entire years of his life to making the consortium run and keeping all these cats together. In managing a number of physicists is bad enough, but managing a number of computer geeks is almost impossible. However, Jean-François did it, and so here's another very crucial person in the history of the web. And finally, you can all buy T-shirts about the 20th anniversary of the web, but we had T-shirts that we ran around with, that I went downtown specially to print on a very special printer, with Tim's original slogan on it. And Tim's original slogan was, "Let us share what we know." Thank you.
Thank you very much. Thanks. You can go. No, we're going to do it. We're going to take care of that. It's okay. You can sit. Thank you very much. So we're going to start the discussion now, and a gentleman is going to join these people. He's an English computer scientist. He's the inventor of the World Wide Web. He joined CERN as a consultant in 1980, and in 1989 he made this proposal. He's the dream of a conference organizer because he doesn't need an introduction. Please help me welcome Sir Tim Berners-Lee. Microphone. So, gentlemen, you all have a microphone in front of you. We're going to get the discussion. Tim, you don't need one, you have one. We're going to get the discussion flowing about the history of the web. We're going to take questions in 10 to 15 minutes. So if you have some questions, you can prepare them. I spent a lot of time discussing with you, Ben, about the history of the web. And one thing that struck me is how much resistance you guys faced. Why was it so hard to persuade people that it was a good idea to do the World Wide Web?
Well, I talked to you about the resistance to bringing in things like TCP/IP. Unix came in pretty easily in a small way. The workstation project came in well supported by management. The TCP/IP was hard to persuade people. There were complicated political reasons, which I mentioned actually in my talk. But the web itself, in my opinion, when it came, it just wasn't understood enough. And there were all these distractions, this little distraction about the LHC accelerator and things like this. And it just was difficult to get people to put money into something which just seemed marginal. Remember, CERN is full of smart people with good ideas, and this was just another smart person with another good idea.
Tim, your take on this?
Well, I think absolutely. CERN's full of smart people. Somebody's creative as the average physicist given a computer is going to look at it and think, wow, well, I can improve on that, or I can. And the temptation for somebody who can program to think, ooh, if that menu were a little different, ooh, I could, oh, look, I've rewritten it. Hey, why don't you use my version? So there's a lot of that which happens. So CERN has to have these really strong are sort of rules that they're sort of not invented here, rules that if it's not invented here, you buy it. No, you don't make it. So there was partly that. There were also some of it was seen as perhaps as a threat to some of it was integrating all these these documentation systems, but some of those documentation systems wanted it to become the ultimate big documentation system, which would enclose all the other documentation systems. And in fact, I think the main thing was the idea shift, the paradigm shift. They didn't understand it because they couldn't. You could show them one. Like on the screen there, you could show them one hypertext page, and you click on a link, and bing, another hypertext page, and they say, "It's a big deal." So,
what's the big deal?
Right,
really?
yeah. So why do I have to put all my stuff into the angle bracket so that my stuff will, run on your program? Because they couldn't imagine what it would be like if that link could have taken us to anything on the planet.
I think we saw on the picture you showed, Robert, that actually there were like 5 people around Tim and 20 people around somebody else that we won't remember. But one thing is that there were a lot of competing systems, right, at the time. And it's hard to imagine now that I should have said, please switch off your phones.
It's okay, I'll answer that. What he mentioned is very important. Every document system wanted to be the documentation system, and he came with an idea, say, yeah, let's all share what we know and link with each other for free. Well, that's okay, but the key invention, people think about the web, they think of HTML. I think HTML is the key invention in the web, and they talk about endlessly about how HTML should improve and how presentation should be separated from content, or if we should have more control over it. It's not the key invention. The key invention is the URL. The URL is the thing which you can write on a piece of paper, on a napkin, and send to someone and type, and which points you to a document, which points you to something, to some resource, or to a person. That is, to me, the simplifying element that was very, very hard to grab for most people who were involved with the web in the early days.
And another thing that really struck me is the fact that your original idea, Tim, was going 2 ways. I mean, Jean-François talked about it in his introduction, but basically Web Beta was Web 2.0 in the way that from the beginning you envisioned the fact that it would be a 2-way thing, and it didn't happen. Can you tell us a bit more about your original idea and your view on Web 2.0?
Well, so Ben mentioned the remote procedure call project. So that was a project, again, it was actually the effort was put in by people who are using it, people in different labs across the world, and people who would join, students would join the project for a year. So I wanted people to be able to join a project, get up to speed by just browsing stuff, and then work in a hypertext environment. And the idea would be, it would be this big, like a big sand pit or a big communal Lego set in which you design a bridge. And so that while you were having meetings, or whether you were remote or local, you would together construct a hypertext about how you were going to make something. So that when you'd finished, there would be, for one thing, you'd have this big hypertext documentation about which anybody else could get up to speed in, and also you'd have all the pointers to why you made the decisions. So somebody who just didn't understand it could go back. So yeah, the idea was that when you were reading a document, if you thought, oh, that's interesting, you could, that relates to this. You'd select this, say mark it, and you'd select, what you'd write. This relates to the other thing, and select it and hit a key, and there'd be a link made, and you'd save everything back. So it was supposed to be just an editable hypertext mess. And the editable hypertext mess was supposed to be,
just an easy-to-use Wikipedia, basically.
Exactly. It really sounds like Wikipedia a lot.
Right. And now people have Wikipedia, but they have to write in these weird languages. People seem to really like.
But why did we have to wait 15 years to have Wikipedia, or maybe 10 years? Because it was your original idea, and it didn't happen. Why?
Well, I think it was because the next system was so much more advanced than anything else. So it was really hard to port the elegant system that was on the next to anything else. And whenever I give this type of presentation at greater length, I say that the big mistake probably that we made was to bring out the line mode browser, because the line mode browser that Jean-François talked about, you saw text, and people thought, that's great, but as you said, We should improve on this, right? They didn't come to us and said, is that what you got? What are you planning or whatever? And they said, no, I'm going to improve on it. They had no clue that we were already much further. And so they went off in all sort of different directions and did, of course, with Mosaic especially, the obvious thing, namely bring out something that was a reader but not a writer. And I think we lost about 5 years, at least, I would say 5 years conservatively estimated.
So what happened then as the future went on? We came across this group called Griff, which had spun out of Veneer, and had a hypertext editor which was really nice. And we tried to persuade them to make it a web. Unsuccessfully, they said they wouldn't do it unless they had funding from the European Commission to cover their costs. Even though we said we'd given them the code to do it. But that later on, the consortium adopted a version of that as what is now Amaya. And Amaya is now has got a lot of the ideas, the sort of the feel of the original web browser. And you can download it, and you can run it on even on a Mac, which is sort of the equivalent of the next. But the experience with that is that actually just having the editor isn't enough. It was also the fact that when people talked in a group, they need to be able to define the group and allow only people in the group to access it. So it was a whole lot of social engineering which we hadn't done. So we didn't, the authentication was very crude, and we didn't have the ability to create groups on the web. People could only create groups on local computers and things. And in fact, the ability to create groups on the web, something we're still trying to push for. 20 years later, where the groups are still local to social, the social networking sites. So that's all another important part of the puzzle which we hadn't developed.
Robert, you want
to
say
no, I missed your first question because this horrible device rang, and the only reason why it rang was to send me an advertisement from Orange because I switched from France to Switzerland, and it takes some time to do that. So I apologize for that. It's not my fault, and it makes me hate advertising even more, but never mind.
Thank you for the precision. Maybe they will stop doing that next time.
Anybody from Orange here?
Do we have someone from Orange who wants to say something? Okay. You talked about adoption, and obviously adoption took a lot of time because the idea was so forward-thinking, and I guess it was kind of frustrating period a bit for you guys. But Ben told me about you had all these other protocols at the time competing with you guys, like Gopher, like Usenet. So can you tell us a bit about how the web took off? I remember Ben telling me the story of that one after one you would be above the other services in terms of usage, and the highest usage was actually FTP. And one day you bet FTP, and now FTP is probably like 1% of the traffic. Can you tell us a bit that story about how the web was adopted and how it became mainstream?
Well, the first sort of technical political move was to make this URL start with a scheme which had a colon, so that anything which was on an FTP server, you could make a URL up for. In fact, people spent a lot of time. FTP was very popular. Have people on the phone saying, you can get it with FTP. You have to log on to alf.cern.ch, and then you have to change directory to foo/bar, and then you have to get a file called baz. So the URL was then, so the web software, if you typed in FTP colon //cern.ch/foo.bar.baz, it would just, you could put that into one, all that those instructions into one line.
So from a web browser, we could browse all the other protocols.
So the web then automatically, by dint of a little bit of software adaptation, every web server, every web browser could access so that everything which was already on FTP was deemed to be part of the web. Similarly, everything that was on Gopher was part of the web. So we kind of cheated. But in a way, it was important. I felt it was important that we should be able to incorporate old systems, because if you could show that you could actually have a system which incorporates the old systems, then you had a chance of imagining that you might incorporate new systems which you hadn't invented yet.
We're going to take some questions. So I have a microphone here. There's a lady. So please raise your hand if you want to ask a questions. I think we have a question right here. I'm just going to ask you one more thing until the microphone reaches that gentleman. You mentioned, so you made a lot of decisions 20 years ago in the design of the web, and you were helped with this fine gentleman. basically, for example, including the other protocols into the web browser. Is there any decision that you made that you regret? Is there something in the original design that you would do differently now?
Well, I've got my favorite. Can you think of is there something which you?
Tell what your favorite is, then I'll tell you mine.
All right. So this famous colon was to separate off the HTTP, and then after that there was something which was very much like a distributed filing system, where if you said /foobar, that meant something on this system, but if you started // it meant on something on another system. Now it turns out that whenever people use, the idea was you could just use // to point to another web server, and you didn't have to put the HTTP, but people always do put the HTTP. So if people always put the HTTP colon, actually you don't need the //. So that's an awful lot of that's an awful lot of bytes across the web. It's an awful lot of characters typed on keyboards. So in fact, in the design, one could have removed the //
I remember spending hours explaining my friends and my grandmother that / is different from \. Oh. Yeah. It's a very tricky character for somebody who doesn't know computers. Jean-François, what was your favorite?
Well, there's a funny one that I was really opposed to the name World Wide Web. It was very hard to pronounce, and even now I have trouble saying it. And only one guy really understood what to do with this World Wide Web name, which, by the way, is the longest abbreviation you can have. It's WWW. It's much longer to say than World Wide Web. But actually, a singer called Prince in '97 on his album Emancipation made a song that goes like this: www.email.com. It was fantastic. I never thought this name could be turned into a song. Only another genius could do it.
Thank you very much. There is somebody who's not a genius who also stole his name from the W thing. He's gone now, thankfully. We had a question there. Can you please stand up, tell us your name, and ask your question, please? You need to, it's under the microphone, there is a small mute, no, under it?
Yep.
Okay, that's the one. Okay, so I'm going to repeat your question. I'm sorry, I cannot give you my microphone.
Microphone array.
Okay, I'm lucky there is no TV here.
Third time. My name is Roger Cruijff. I'm just another journalist. It's a question for any one of you, or maybe for the Director General of CERN, but in 20 years from now, will CERN be remembered for its core business or for this spin-off that was born here?
So who wants to fill that question?
Anybody here from CERN?
I vote for the core business. I vote for the core business.
It'll be remembered for the core
me too.
business. And
Yeah, me
have you been down?
I think so as well.
Have you been down to look at the tunnel?
The LHC.
You have?
Yeah.
Right. So I think it's something that people will remember. Of course, the big result is just around the corner. So
In October, it's back online,
Right.
we've been told.
don't hold your breath.
We had some other questions. Maybe I'm going to steal a microphone from you, and you can pass it. I'm sorry. If you could just tell us your name and ask your question.
My name is Oscar Barbala. I was in the PS division in 1980. And I would like you, Tim, to maybe to say a few words on what I would consider the prehistory of the web. You mentioned the zoo among computer people. There was another zoo among accelerator people in the PS division at that time, and you did contribute a little bit to solve that zoo. Could you mention it, please?
The PS.
Tell me.
Okay.
Let
Now you're going back for.
Yeah, he's going back far.
So this is actually
Inquire.
PS is where Robert and I met. I went
The first time.
So they met the first time. So that was back in 1980.
Yeah.
The PS, like many wonderful projects, the PS control system had a crunch. It was going to be turned on, and there wasn't. And There wasn't going to be enough time to finish it, so they brought in a bunch of contract programmers, and I was one of those. I was there for 6 months, and it's funny that when I left CERN in December, I felt that I completely knew the place. I'd been in the Alps in the summer. I'd skied in the winter. I'd learnt to ski pretty much. I'd had the full CERN experience, and that was only 6 months. Little did I know what was to come. 4 years later, when I went back. It was an environment where the reports I look at were written, they have on the front that they were printed off using the report software, which was written by Robert Caillou. And the compilers, the things.
Yeah, you wrote Inquire at that time.
I wrote Inquire because I came along and and somebody who has difficulty remembering names and how people connect with things. I found this melee of people doing different bits of hardware and different bits of software. So I wrote a little, just simple thing that ran on a text terminal where you could you could follow through links by typing numbers, and when you found a relevant place in this document, it was a map I was sort of keeping of a set of notes about the system, and you wanted to add something on, you just add a new card, and you'd always have to explain how the new note card was attached to the previous card. And this is all on one of those old green 24 by 80 terminals. And the thing was called Inquire, named after a book, Inquire Within Upon Everything. Robert seems to have there. And there is, in fact, so I did write a little bit about it. But when I left in December, this was ran on the Norsk data machine, under the Cintran 3 operating system. It was written in Norsk, something or other.
I think you wrote it in MyPascal because that was the only one that ran. But tell me, that did not run over the network.
But it didn't. Well, the internet, of course, was not on the machine.
No, but we had a network.
There was an amazing network between the traditional way. If there's any computer scientists in your audience, the way one would communicate over that network was that there was a convention that all the line numbers of the program between 5.1 and 5.95 could be referred to as group 5, and you could just say execute group 5 on a machine on the PS Booster machine.
Yeah.
And so the machine, so it would take a bit of your program, it would send it across to execute it in a different environment, and then return the results. So that you could even also change and then you could then say line 9.5 equals and give a string, so you could change the program before we went over to be executed again. So it was extremely hairy programming. There was a wonderful system.
It is hairy. It ran. It's called JavaScript today, I think.
Code, right?
Terrible program. But I never asked you the question, so I'm going to ask it straight now. When you left, you had Inquire, which was some sort of a hypertext program, right? Mm-hmm. But it didn't run over the network. However, I do know that since you worked in various places of that control system, you must have had, you can say what you like as an answer, I'll accept anything you say, you must have had then maybe the idea that it would be a good idea to be able to access that over the network? When you were in some other place?
You could log in remotely to the system, and also on different machines of the system had shared file storage. So that
so that idea of running the link over the network did not occur to you then at that time?
It wasn't appropriate to that environment.
Okay.
There wasn't. You couldn't really run a client server.
No, I just had the idea that maybe at some point when you had just gone away or so, you might have thought, well, I could add that to it, and then forgotten about it for 10 years, but... that wasn't the case.
But the topology of the system was was very hypertexty, and the disk the program was stored on an 8-inch disk, and I gave it to the system manager at the time, a gentleman called Brian Carpenter.
Yeah, not here today.
Where's Brian? Yeah,
I think that it shows these guys haven't seen each other for a while. We're going to have time we're going for dinner afterwards.
Brian became the.
We're going to take one more question now, and you can ask more questions to Tim after his talk at 4:30. At 4, sorry. So don't panic if you couldn't ask a question now. We're going to take this question and maybe talking about old computers and old environments. If one of you guys could do a demo after, that would be great. We'll try that. Your question, please.
My name's Ed Harris from Reuters. You've spoken quite a lot about the past of the web, but can you tell us about the future? How do you see the development of the web? Where will we be in 5, 10, 20 years' time?
Could we take that question for the panel after? Do you mind? Are you in a hurry? Are you staying with us? Because we actually have a panel on the future of the web after. So Tim is going to talk about that also in his keynote address in 30 minutes. So I think it's better if we take that after. So maybe we have one final question. I won't forget you. You will get to ask your question. I'm sorry. We have a gentleman here. Please tell us your name, and the microphone is coming.
Yes, my name is Gabriel Minder. I'm talking from prehistoric times. I was the Director General's left foot in the 1960s. So my question goes back to what Groff said before about the name. Often I was asked, how did the name come, easily or what? You mentioned it partly. WWW is quite something. Mind you, the Italians have taken a nice shortcut. Woo, woo, woo. That's nice. But my question is, has there been a consideration from many angles for that abbreviation? For instance, you could call it, I don't know, YYY or ZZZ. I can imagine. But my question is only how many contenders for the final selections were there?
Well, I've read in Tim's book that one of the considered names was the information mine, but he thought it was a bit too self-centered, so he chose something else. But
right,
Tim,
mine of information would have been moi, even again more self-centered. So I knew. So this, you know the RPC project which I made before that. No, there's a few people nodding, but you don't. You don't know it. It didn't take off. Oh, nobody actually. No, but it was used in a few places. But one of the problems with that I found was people call it Tim's RPC project, and RPC is a generic term for remote procedure call. It didn't have a name. And all the projects, they all had Pegasus, Mercury, so yeah, so it had to have it. So certainly I knew that this thing had to have a name. Also, I noticed, say, René Brun is here. Okay, at the time, so at the time, that was in the days of Zebra. Everything that René produced of any sort started with Z. Okay, it was. Okay, so it's so he picked an obscure letter, and in those days when you programmed and you wrote a new procedure, you had to make it a name, guess a name which nobody else would think of. So a typical thing to do was to make it unpronounceable. So starting with an obscure letter. So there were quite a lot of projects that started with K's. Actually, probably lots of synths that started with Z's. But when I wrote the code, actually, I started it was HTML and HTTP, and so all the code started HT. But part of the decision was that I needed an obscure letter, so W was one. And then I thought about calling it the mesh. Sounded a little bit too much like mess. Even though one of the suggestions was that was a problem with it, it would turn into too much of a mess. So World Wide Web was actually what it was supposed to be, a global mesh. And web is actually sort of mathematically sort of the distributed. Acyclic graph is kind of what it is. Sorry.
The good thing about this disastrous branding in terms of pronouncing it, I mean, nobody in his right mind would put out a product to the masses with such a name. But the good thing is that because it was very hard to pronounce, people had to repeat it so often, and it stuck. So you couldn't forget the World Wide Web once you first heard about it. That was a big factor in its adoption over Gopher and all the rest.
Right. So, I checked on Google and nobody'd used it.
Robert, Tim, do you guys want to do a demo maybe with of the first web server, a short demo showing us? I know it's not connected to the network. Yes, I think we can project it. There is a switch here.
But. Yes, the but is that there are many buts. I'll switch it on and we'll try. One of the things it's going to do is that it's going to look for the network and it's going to try all sorts of things. Let me switch it on first. And I really don't promise anything here because, as Ben pointed out, every time you switch one of these machines on, that say, well, the power supply, the machine is okay, but the power supply contains capacitors that don't survive very long, so you risk blowing it up. Now, fortunately, Mémoire Informatique, Yves Bolognini, who is, where is he sitting? Here. There. His club produced a special cable that we're using to extract the monitor signal and put it on the projector, because this machine didn't come with a cable for a projector, and it was impossible to do that. The later machines did. So we have we thank him, please, for that, because otherwise you wouldn't see anything on the screen there.
Yes, thank you.
And if anybody of you has any historic devices, throw them not away, throw them into his direction, because he will take care of them. Right, so now it's going to hang there for a while, looking for the network, and it's not going to find.
We should have started it in...
Yeah, well, yeah, I know.
Mode, so we could,
yeah,
so
but I'm even more... I'm even... Tim.
Hold on.
Still faster than Windows.
It's, you know, this. Remember this. So this next step operating system was. We had all kinds of novelties. The machine had a signal processor. It had a optical drive before DVDs and CDs and things. It had a read-write optical drive. It had all kinds of nice hardware. It had fairly, for the time, a high-resolution display, which even this projector seems to be having fun with. And it's got this operating system was Unix on a personal machine, which was kind of a first and nice, interesting version of Unix. And it also had, it had Steve Jobs' feeling that it should be really easy to use, and you should be able to use it like a refrigerator or something.
And it's already booting faster than Windows Vista.
Yeah. Well, it's not doing doing anything at the moment. Oh, and now
it's working.
I'm going to.
So that's that pause was because it was disconnected from the network.
That long pause was just waiting for the network, not doing anything. Now it's going to ask us for a name and a password. And some of you will recognize this behavior.
Yeah.
So that's how old it is, right? Okay.
Yeah, basically Mac OS X was outgrown from the next operating system. So
there
you see the legacy even in your iPhone today.
This thing was just, I think, 10 years ahead of anything else that was on the market at that time. And that was one of the reasons why it was so difficult to get the web to demonstrate it even to somebody else, because you had to take the whole machine with you. Okay, there we are.
Now, mind you, the default place for the dock on the Next was on the left-hand side.
Was it? Did you do that?
I still...
Did you do that?
I had my dock on the left-hand side. It just comes up on the left-hand side. That's why it's on Mac. I stick my dock on the left-hand side because that's where I'm used to it.
No, the standard place for the dock was on the right-hand side, Tim. Believe me, the standard place for the dock was on the right-hand side on the Next.
Oh, maybe I moved it over
the menu was on the left.
Yeah. Oh, okay.
Yeah, the menus were on the left.
All right. Maybe I moved it over then.
Then some people...
Some of the nice things...
So the icon... there is a globe from some other Mac Next icon with a little painted. The fourth icon down on the right-hand side is the icon for the sort of a globe book with a globe and hypertext link. So it's a kind of a hack.
So and I can now.
So that was the first pop-up.
I can now make a new page,
spinning wheel,
and I'll have to save that somewhere, and I'll save it under guest. Yeah, okay, fine. Why not?
So editing files.
I'll say, do you want to replace it? And I'll say yes, because whatever.
You're replacing the blank.
So now I have a new browser page up, and we can just go in there and type. You see, but we can also link it, of course, and read it. And if there were links in it, we could just click and follow the links to different pages.
So let's make a link. I'll make the link, you talk.
Okay, you make the link, you talk. He can do it better than I can. But that machine, just to situate for the computer geeks in the room, the machine shows you on screen everything in display postscript, so it doesn't run a special graphics thing. It is just postscript there and then directly, which today on Apple machines has gone to PDF, which is even more efficient. Okay. But
so
that's what
see
it
what
is.
Jean-François is doing. See that there's a link menu. He's ripped it off, which is one of the neat things you could do with the menus on the Next. So he's got it permanently there. And the top, and the way you make a link is you mark something and then you link to it. So the thing remembers the marked thing. So you can mark either all, or you can make a selection and link it. So and then you click link to marked. And ta-da! Woo! Okay, so that is how easy it should be to make hypertext.
Of course, it's no big deal to do that on a local machine, but this worked all over the internet and talking to any database system that was interfaced to the web. So that was the key. And behind this little click movement that I make, actually what Tim did is there's a style of text here that has an unused attribute. And he said, let's use that to store a URL. So when I double click, the software reads the URL from this document and it calls the network stack to catch the document that is described at this URL. And then you get the page and you display it. It's that simple.
So there's a few things which are different. So one of the things is you notice compared to a normal browser, if you want a new, so the default is to make a new page. So that you end up filling up with, if you follow all of the links, you can, now, can we follow, no, we can't follow to CERN.
I think we have no outside
network.
Of the network.
How about the navigate menu? Often there was a case that you'd be going to something like a news page or something.
Notice Next had detachable menus. They gave that up when they
now
switched
the
to the
meaning of
Macintosh.
back, next, and previous is completely different from the current browser. I noticed that people who use Gopher, for example, they're in a tree. Lots of parts of the web are actually like a tree. So that if you've got, suppose we follow the.
Go ahead, speak.
Okay, so if we follow the Let's Go link, we'd end up at Welcome to Universal Hypertext. Then often what you're doing actually is following, you're looking at a set of documents you've been given. So what you want by next, the next operation you want is go back to the previous document I was at, find the link I followed, find the next link after that and follow that instead. So that if you have a list of things, you can just go down that list in another window.
This is where the URL is sitting. It's behind the scenes. Nobody should see the URL. You see, it's not even in the title bar. We thought normal people should not see the technology.
Yeah.
Well, they wanted to see it.
The document an inspector on Mac or this is like Windows properties. This is sort of something you shouldn't see unless you really want to get your fingers messy, right? So you see no angle brackets, no HTTP://.
So this machine was connected to the network.
Real men don't do that. Real men type URLs. You know.
Maybe there was something strange about
that.
Give people a geek feeling.
I remember on AOL, a real man had to type some keywords, and that was very crappy.
It's exactly
so that was this computer was connected to the network, and it was the first web server, right?
Yes. It was the first web server.
It has been the whole web for a couple of
it's info.cern.ch.
Not very long.
Not very long.
It was the whole web for how long? When did the second server come up? I mean, Nikef and Daisy.
The CERN phone book, maybe.
I have got a list, which was I kept. In fact, I went to a conference and didn't trust the network, and I took a copy of everything on this machine on a floppy disk. That was how big the web was at the time. Took it to a conference in 1990. Was it November 1991 or something? And I had a list of web servers. I kept a list of web servers at that point. I gave up after a while, but at that point there were 26 on the list. And there was so that disk has ended up on the on the refeeder.org website. There is in fact there is a frozen archive of that, and you can look at there's a list of the clients that you can use and a list of the browsers that you can use and so on.
I'm demoing the styling, okay? No CSS, no nothing. You change the style just like on your word processor. That's the way it should be.
And but it's calling it style, but actually you're setting,
there is a style sheet behind, yeah. Yes. It's just hidden.
Yes. Yes. Many years later, there was an attempt to say that
somebody invented CSS. Yeah.
But and then later, somebody claimed that the style sheets were patentable.
He's sitting there.
Yeah.
guy who, I thought the editor window, the browser editor window, was done by a French guy whose name I forget, and that was all done before you.
Oh, this was...
this thing, I should say, all this pretty much, this was really, really easy. All the work had been done for me. So there's a program that you can run which isn't up here. Is that? No,
it's not here.
a thing called the interface builder, which you can...
No, the interface builder is not...
it's in the development kit. And
of course it's
so
here.
you can just say, I want a new project. I'm going to call it World Wide Web, capital, capital, capital. And then you can drag in the menus. So that link menu, I just dragged things in, new menu item, new item, new item.
Create a new application. Look at that. So I'm creating a new application.
There we go.
I'm going to take a text field here. This one, that's the big text. Okay, I'm going to take a text field.
And already inside that text
and make
field,
a big thing. And now I can... Sorry, Tim, go ahead. Now I can go and run this application. There was a test mode. I know we called it with command R, run, yes. So now I'm running the application in test mode. Well, disclaimer, I worked for Next after I worked for CERN, so I did these kind of demos a lot of times.
Well, anyway, what Jean-François Groff is trying to say is that building the software was almost a play on this system. And then, once it was ready, we had to take it out to the world where there were only text systems and Windows machines and whatever. And it was very, very hard to go away from this and put it somewhere else.
So
I cannot do much with this.
There's all the ability to cut and paste.
I will add a feature.
So already... The text object has got the ability to put, in fact, to make different fonts.
Look, I'm adding now a font menu to my application, okay? And it's predefined with a few actions. So now if I run my application and I type my text, is a great invention. And I can go great invention, font bold. That's it. So what Tim said, he created a custom attribute of text and said, let's put a URL behind that.
So
right? That's what you did.
Right. So if you look at the software behind that, there's that little piece of text, great invention. There is a memory structure which has got a little sort of flag for whether it's bold, a flag for whether it's in italic, and a pointer to the font, and the length, and the set of characters, and a 32-bit field reserved for future use. And I thought, that's me. And so... that became then a pointer to the anchor object. And yes, we met the guy the French guy that wrote the text object.
Jean-Marie Hulot.
Jean-Marie Hulot.
And Bertrand Serlet.
And the documentation said you can subclass all of these, all the objects in this, except don't subclass the text object, which is just what I did. The only thing I did subclass, pretty much. And so he'd done a huge amount of the work beforehand. And
you make it look very easy, but I'm sure it was.
Yes,
you had a lot of merit doing that.
As well, but that was pretty
Ladies and gentlemen, can you give a big round of applause to our 4 speakers? Thank you very much. Thank you very much for talking about the story of the web. We're going to take a break now. You can have a look at the computer also right now and later. We're going to take a break and we'll be back at 3:30. During the break there will be a presentation of a website launched by the CERN for kids. It's called CERNland. It's going to be a video happening now. See you in 20 minutes. So what we're going to have now, CERN, first I'm sorry for saying that we started at 3:30. Actually it was 4, so we're not late. I was a bit too much in a hurry. Right now we're going to, we start 5 minutes early because the CERN is launching, we're talking about the future of the web, and CERN is launching a website, an initiative to educate kids towards physics, and this is what is going to be shown. It's a 5 minutes video you're going to see. Then at 4, Tim is going to address the audience and share his vision, basically tell us the project he's working on. And then we're going to have a panel on the future of the web, and we're going to take the question from Reuters at that time. En français, nous allons reprendre la conférence. Nous allons commencer 5 minutes en avance, puisque le CERN lance une initiative qui s'appelle CERNland et qui veut en fait sensibiliser les enfants à la physique. Et donc il va y avoir une vidéo de 5 minutes montrant cette initiative. Ensuite, nous aurons Tim Berners-Lee qui viendra parler pendant une vingtaine de minutes. On fera une session de questions-réponses. On a des questions qui viennent du web que les internautes ont posées à Tim, et on prendra aussi des questions dans la salle, et je favoriserai la gauche de la salle, puisque j'ai favorisé la droite de la salle au début, paraît-il. Ensuite, nous aurons un panel sur le futur du web avec 4 speakers qui viendront rejoindre Tim pour parler de ce vaste sujet qui est le futur du web. Je retourne en anglais. To introduce us to CERNland, I'm calling Silvano De Gennaro. Silvano, you here? Please tell us a bit more about CERNland.
Okay, well, thank you very much. I just want to say a few words because he already has introduced the concept. CERN is, in its communication policies, trying to really get down and talk to the young people. We want to motivate young people to study science, and particular physics, and hopefully some of them become physicists one day, so we can have some fresh water coming in. We're all kind of growing up. So we wrote this little program and this little game website called CERNland, which is directed at a young audiences, really kids between 6 and 12. I guess the video is going to tell you some more about it. So perhaps just send the video and you'll know everything about it. Here you see the accelerator control facility. You have to try and get that particle on the other side. This is CERNland. This is called Super Bob, which reminds you a lot, I guess, of Super Mario Nintendo, except this time you have to answer questions about the accelerator. Every game is a learn part and a play part. So you can learn before you answer your questions.
Yes. Yes.
We target an age range of 7 to 13. That's when kids discover science. Also, at that age, their imagination is so completely unrestrained that they can easily grasp some pretty awkward concepts as those you find in particle physics.
It's really good, yeah. Because, well, I learned a lot when I was on it, and the games are really fun.
Not with little rockets which go into the sky and you have to get neutrons and other things.
So you need to find out things and you need to figure it out, and
like how long the accelerator is and what antimatter is.
Well, they're definitely more fun and more challenging, and they learn new stuff at the same time while you play.
Bah, qu'est-ce que c'est l'LRC et puis qu'est-ce que c'est CMS.
Voilà.
C'est beaucoup moins violent déjà et ça apprend beaucoup sur le CERN.
I think I learned quite a lot with it,
yeah. Il y a tout type de jeu.
Yeah, I got a diploma from amateur fraction.
J'ai bien aimé parce que les jeux c'est bien expliqué, des questions et tout, et on apprend beaucoup.
You have to go up and try and get all the different atoms and stuff, and get as many as you can, and then they get more difficult as you go along.
Well, we had to collect like an amount of neutrons, protons, and electrons to complete the level, and there were 18 levels.
I think it's very interesting how you can make all the different types of atoms, and also Super Bowl because it's fun that you can explore the whole LHC.
So, of course, as you can see, we have tested it on some guinea pigs supplied by the International School of Geneva that we want to thank. And this was upon the request of our Director General, saying, you know, I don't have to like it, but they have to. And as you can see, they did.
Standalone as it is today is already a very good start for kids. It's a completely new tool to play with our laboratory. It has a very bright future ahead. We have already thought of 2 new game environments for Sandland. One is about physics, so it's a nice journey through the history of the universe. A second one is about technologies and the link between science and everyday life. So I can already anticipate that kids will have a lot of fun with Sandland in future and today, of course.
It's great to be using the 20th anniversary of the World Wide Web to launch CERNland, which is our new website for young people, and it's a website that brings in the latest in technologies. It's multimedia, it's interactive, and it's designed to share our enthusiasm, our passion for the science that we do with the young generation today, because after all, our future is scientific and the young generation are our future.
I hope these people invite you to their weddings because you have a lot of things to show. At LIFT one day, a couple of years ago, we had a scientist called Sugata Mitra who is doing a project you might have heard of called Hole in the Wall. It's a project where basically his office was next to a street and there were some kids from like street kids. And he put a computer there and the kids kind of learned how to use a computer by themselves. And he showed that basically giving a computer to kids is a powerful way to have them self-educate. And one of the most striking video he has is the one of a 9-year-old in a super remote village. And she's in front of a Wikipedia page and she's explaining to a 4-year-old nuclear physics. He has the video. You should check him out. Sugata Mitra. Actually, what he does inspired the novel that then became Slumdog Millionaire, and he was not aware of it. I told him a couple of days ago, so he won an Oscar in some way. Whatever. Our next speaker, Tim, you're very busy today, so he's going to be back on stage and he's going to explain us a bit what he's working on. He's going to speak for 20 minutes and then we're going to take some questions. Please welcome back Tim Berners-Lee.
So Laurent, I'm sure when they planned the agenda, thought that I'd be speaking for 20 minutes. He didn't realize that I'd spend half the morning speaking and probably half the rest of the afternoon too. But hey, it's good to be back here. It's, funny looking at the Mont Blanc for the first time in a while this morning with the sun rising behind it and realizing that actually it's pretty amazing, but when you live here, you take it for granted. I realized that actually, when you work here, you can take it for granted too. When you work here, you can get used to being in a place which has got lots of cool, interesting people which have come from different countries and speak different languages and have got different ideas about how the world should be. And I presume that you still take breaks for coffee and discuss these things. I hope it hasn't. The management hasn't got to that yet. And the environment at CERN, it's good to be back, it's good to remember what a neat place it is. For me, I have lots of fond memories. Good to see again, of course, old collaborators, people who worked with sort of directly and indirectly. CERN, in fact, for the people, because of the mountains and skiing and stuff, but largely because, for lots of other sort of more serious reasons, was a great place to start the web. It's this microcosm of the world in some ways, because it's got people coming from all over the place. So it has the heterogeneity that the World Wide Web needed to address. If I'd started it somewhere else at a university in one country, maybe it wouldn't have had that. It has physicists who come to CERN and they're not under this very strong rule that they shall all use the same computer. They're not all told to use Macintoshes. They're allowed to use other computers as well. They're allowed to. So they bring lots of documentation systems. So they have this heterogeneity, and which sort of reflects the creativity and the variety of places they've come from. But as they also, therefore, have a problem. They had a problem. So CERN was a great example of a place which, in a way, was hurting because it had different documentation systems on different sorts of machines, using different formats, using different programs to get to them, and even sometimes connected through different networks because the internet wasn't all connected up yet. Also, of course, physicists are early adopters. To solve these huge problems, physicists build machines which are bigger than, weirder than, and things which have been built before. There's generally a shortage of money, so they have to be creative. And they're always pushing the technology in all kinds of directions. So if you want to sell somebody on the idea of a documentation system which is not a matrix, and is not a tree, but can be all of those, or sometimes all of them at once, then in fact CERN could be a good place to start a new idea, a place full of early adopters. Of course, so this day, actually the actual exact date, I have to admit, is actually a sort of a created one, because I can't remember which day it was. I actually wrote the darn thing. I was probably thinking of it all through February. But anyway, so we're celebrating this, but in particular, what happened to it. So I wrote this because I wanted to push the idea around, and somebody suggested a memo would be a good idea. I wrote it 20 years ago. 20 years ago, nothing happened. As people have mentioned, a year later, actually, this is March 1989. The version that I have has March 1989, comma, May 1990, just to rub it in, that if you're reading this now, actually you could have read it a year ago. But so it was actually in September of the following year that things started to happen. And they happened because Mike Sandel let me, and what he let me do was not do the World Wide Web. What he let me do was buy a Next machine. So the order in which it came in, he said, yeah, okay, let's buy some Next machines. I agree then it needs things, and we're going to need a way of testing it. So it was done. He didn't really give me the nod for the World Wide Web, except he gave me the wink for the knowledge. Okay, we're going to test the Next computer, okay, and why not invent some? He left me up to me what program I decided to test it on. So that's how it happened. And after that, it took off because people across the planet, random people got involved. And that's the most exciting thing about really with that spirit. It was the spirit of the internet at the time. I could give a talk. I wouldn't get quite as many people as this, but maybe half as many people in the CERN DD auditorium as it was at those days. And maybe at the back, 3 people, some scattered throughout it, would get it and think, ooh, I might code that up. And they may be young people who would go off and make a web server. And the rest would be confused, puzzled, feel threatened, not understand it, be worried about it for one reason or another, or whatever. But that's all it takes. Because if I gave a talk and 3 people picked it up, and they went away to their institutes and gave a talk and said, by the way, within my experiment, we're going to try, we got a World Wide Web demo, and 3 people then pick it up. Actually, that's enough. All you need is exponential growth. And exponential growth was what we had. The load on that machine as a server went up by a factor of 10 every year. Every month, we look at the logs, and they'd be 10 times as long as the logs back a year ago. And that's exponential growth. If you put it on log paper, you can put a ruler through it. So that was pretty neat. Now, the main design points of the web were sort of there. A lot of them were social, in fact. It was like things like, don't try to get people to change the way they work. Don't make them use a particular machine or a particular operating system. Try to constrain them as little as possible. You're going to ask everybody in the whole planet to give something a URL, give everything a URL. You can't ask anything else. That's a big ask already. You didn't even ask them to put it in HTML. You could put it on the web in any format, but HTML was available if you wanted to use it as the warp and the weft of the web. And so HTML was there really, I imagined, for connecting up a whole galaxy of different types of of information that we'd see out there. We had PostScript files, we had movies. The next was pretty nifty with the different types of information. And so, and HTML was used for linking them. And it turned out then that HTML ended up becoming the documentation language of choice, just because every single browser had to have HTML, whatever else they had. So that was the main, I suppose, the other fundamental criterion was don't make people change the way they work, but also there was this it should be universal. It's no good if you have a web for academia and a web for industry. It's no good you have a web for polished documents and a web for ideas, and then a sort of a way that you elevate things. Because whenever you try to draw a line between those things, there's always things which don't fit in that categorization. And it's always a pain. You always suffer from pain because you want to be able to use the tool you've got for this on one of those. So the web would be just hurt by trying to make it apply to any subset of the information on it. So hence worldwide, hence universal. Any operating system, any hardware, any type of information, any language. Okay, one mea culpa. At CERN at the time, the more or less ISO Latin 1 was the state of the art, and it did all the CERN languages, all the European languages. But since now we have XML, we have XHTML, we have Unicode, we have UTF-8, so now you can do lots of languages. But at the time, the default was ISO Latin 1, which at least was an improvement on ASCII, which is for which all previous internet protocols had, like email had as the default. So, in fact, that's causing a lot of fuss, and still the fact that HTTP specifies the ISO Latin 1 as its default. So trying to make it work for everything, not only just all languages, but all cultures, because it's possible to build a system by the way it works, by the way it asks you to work, to organize your data, actually programs in the culture about how your organization works. That's not going to work. It's got to be culture independent as well. So universality, that was the rule, and it worked. Lots of people got very excited about it. We've talked already about the fact that a really important step was CERN saying that they wouldn't charge royalties. Without that, it would have died. If we had tried to charge a cent for each link clicked or something like that, then people would have seen it immediately as something to fight over rather than something to agree on. And as Ben said, we had to get people to agree on a few simple things. Use URIs. Turn your stuff into HTML. Put it up there using an HTTP server. That's kind of it. It's very simple. But in a way, it's a big ask. We're trying to do it with data now. We're saying, put it up there, give a concept to URI. We're trying to say, put your data up there using it, same old HTTP, and we're saying, use RDF to put data up, and still, there's a huge gap for people to make them. We're in the same state now. And then we've got some speakers coming up, and some of the things we'll address is the state of this exciting move towards linked open data. So that's interesting because the linked open data movement is in a way like as the web was many years ago back at CERN. One of the dangers with celebrating anything and having a 20-year birthday is that there's a temptation for people to look back at this thing that we did and use too much past tense. If you've been reading any of the magazines or looking at the blogs and been anywhere recently, you'll realize that the rate of creative new designs, the rate of development and innovation on the web is actually getting faster and faster all the time. So it's crazy to look back really from here as though this was the web. The web is not all done. It's just the tip of the iceberg. Yes, you think it's been a big change to society, that you can look things up on the web. But in a way, I'm convinced that the new changes, the things which are going to happen, are going to rock the boat even more. When we get all the data on the web, then things are going to happen which are going to be, which will change the world because things will be processed on our behalf by machines. We'll be able to use much more powerful devices. Already when you look at websites out there, you see people have used the web to invent things, all kinds of things which you'd never have imagined. And so coming up, we've got new waves of things that we've never imagined. And the web of data, all these things becoming bases for them. So very important that we have a huge amount to do. Some of it we've got on an agenda. So the World Wide Web Consortium, which they founded in order to be a place where people could meet and talk about and advance the web. So when I left here, by the way, I had to leave here, not because I didn't like it here or I didn't like the mountains, but the internet had grown across the States already before the web. So already the US was all cabled up with internet. People had it on their desks. So when the web took off, it just filled the academic world in the US. So the center of gravity was very much in the US. I really had to be in the US in order to sort of help coordinate the development of the web. Mind you, we did make sure we set up a base. It was going to be at CERN. It was moved, as has been described, to INRIA, and we then quickly got a base in Japan at Keio, to make sure that it's an international organization. So 1994, then, I moved to the MIT, the US base. We started the consortium. The consortium got lots of things it's done since then. In fact, every year there are more working groups, there's more work to do. And it's more need for volunteers to get seriously involved. Some of the things recently which have been important are Mobile Web Initiative. I think Stéphane Boyera is going to talk about that a bit later in very few minutes. Just getting the web onto all those mobile phones is important because, well, one, there's actually more of them. There are more browsers on phones by a large number than there are browsers on laptops. And two, because in developing countries it's really exciting because that is the only way that a lot of people will actually get to use the internet at all. So we can maybe do things which are really important by making sure that the web works well. So if you want to know how to make your website work well on a mobile phone, then go to the Mobile Web Initiative, look up the guides. If you're excited about that, get involved. So that's one area, getting the web into mobile. Another area, which we're going to hear more about now, is getting that data out there. We've had these protocols around for a while. It wasn't until, well, I guess a couple of years ago, and I've told this story a number of times, and I've mentioned how I wrote an article called Linked Data, one of a series of articles I write about design issues on the web. And this one just has a very simple idea about how to use RDF for data. Just say, make sure that you've got, for your concept has got a URI, make sure that it's an HTTP URI, make sure if I look it up, I get some data about it in the standard format in RDF. And we'll also make sure when I get the data back, when the relations to other things, that those are expressed using URIs. So I can look up that data as well. So it's just like hypertext, except it's data. When you put it in, you can do stuff with it. You can graph it, you can plot it, you can calculate it, you can analyze it, you can put it into a spreadsheet. You can do things which you can't do with the stuff when it's in documents. So that was linked data. Various people seem to pick up that idea as being a nice sort of simple expression, because Bitzer, who's going to be on the panel, picked that up and made something neat called DBpedia, which he picked up. And basically, he and others have been part of this thing called a linked open data movement. Linked data, because that's the simple technology it's used for putting this data up. And open because there's also a push to actually not just use the standards, but put that data out there. Actually put data the data behind your website out there. And it's funny me coming to CERN. CERN is a place of data. And I bet there's lots of data which a lot of kids out there would really like to be able to get their hands on. Students out there would be able to get their hands on. Educators out there would be able to get their hands on. There's a standard format to put it, so it'd be great for it to be out there as linked data. There's lots of important areas for linked data. There's government data. An awful lot of data we're paid for by taxpayers, and we as taxpayers can actually ask the government, please, in some cases we can actually demand by law that the government should put that data on the web, make sure they put it out there as linked data so that we can link it up. And when they put information about the town of Genève, and then we can connect it to the information which has been pulled out of Wikipedia, information boxes about the town of Genève, and it can all be put together, and it'll turn into more and more rich resource. There is collaborative data, like the OpenStreetMap project, which allows people to connect, which allows people to edit a map. It's a map. It's a database of places, but it's a wiki map. So you can, if you look at your house and on the map and it's not there, or something's wrong with your village, you can go fix it. So it's becoming a really interesting resource. So this is collaborative data out there. There's social
Networking data, people are getting really fed up with the fact that the social networking sites are hoarding their data. They're starting to demand, give me my data. I've told you who's in all these photographs, and now you won't tell me back. Okay, hello, I want to use the information about who's in which photograph on another website, the t-shirt printing website, because I want to send a copy of a t-shirt with each photo to all the people who are in the photo. And now it's really difficult for me I have to type all that data in again. People are getting fed up with that. They want to break down the silos of the different sites by using linked open data, and it's starting to happen. Dan Brickley's going to talk a bit about that. Dan was involved at the very early days of open social networking on the web. I did a talk, which is now online at TED.com, which goes into that more detail. It's just come online. Now they put it online, although I gave the talk a little while ago. They put the video up just now in honor of the CERN celebration of the 20th anniversary. So looking forward now, the web now is different from back then. Back then, there were 26 servers at one point. Now, there are 10 to the 11 web pages. 10 to the 11 is roughly, I understand, the number of neurons in your brain. The problem is that the number of neurons in your brain is going down with every beer, and the number of web pages is going up with every time somebody fills one in and makes a blog. So the web is very large and complicated. The brain is very difficult, in fact, to understand. We have a science, cognitive science, where people from different disciplines get together, psychologists, biochemists, people do functional MRIs, all get together to study the brain, and they're making tremendous progress on figuring out what some of the bits of it do and how it works in general and what its properties are. But in a way, the brain is a sort of machine with different parts. The web, we didn't design it as a machine with different parts. It's just stuff. And what's happened is emerged. And what turns out that it's a big scale-free system, that there are communities of all different sizes. There are emergent things, systems which turn up of all different sizes that have a dramatically scale-free size distribution. And when you look at it, you have to, it's not just, you don't need just an internet engineer to understand it, because the web really, when you look at what determines whether a link gets made, well, it's the person who makes that link in a lot of cases. So you need a psychologist to understand when people make links. They may be motivated by economics, so you need an economist to figure out what happens when you have a certain when you have a certain kudos level that somebody knows they're going to get if they make the link, or to one place, but a certain amount of money that they'll get if they make it to another place. So we need people who can use many, many different disciplines, as well as computer science, of course, to understand the web and understand things like, actually, is society on the web stable? What happened? Will the blogosphere continue to give us, be a relatively reliable source of information, or will it just turn into a bunch of junk? Will conspiracy theory just take over with the web somewhere, which actually will flip, and not just just one large group? Will occasionally countries in the past have had horrible, unsuccessful social ideas take them over? Could the web now allow that to happen to the whole planet at once? And if that's going to do that, there's no other country, there's no other planet next door which is going to invade and put us back on track. So this regarding the web as something to study is really important. We call it web science. We started a web science research initiative 3 years ago, and it's not just science, it's engineering, because unlike the brain, we actually engineered the web. So if we decide that it's got a problem, we actually can change the protocols and rerun the math and figure out so that actually will be stable and it will be better. So the goal of web science is that the web should be really cool. Web should be. What's the goal of web science is to really understand the web. Why? What's the goal of web engineering? Best way we could put it was that the web should be engineered to serve humanity to the optimal. And when you put it like that, then when you step back and you think the goal of web science is that the web should serve humanity, and then you realize that actually it ain't just science we need. We've got W3C is producing standards. We've got people doing research about the web. But really, the moment you say to serve humanity, you realize that, whoops, 80% of humanity doesn't use the web at all, for various reasons. A lot of them actually they are within a signal area. If they had a cell phone, maybe they'd be able to use the web. Maybe they have a cell phone, though, it doesn't have a web browser. Maybe it has a browser, because a huge number of them now do have web browsers. Maybe the web browser doesn't work with this website, or maybe it does work with this website, but the characters don't. In principle, it works, but they don't have those particular Ethiopian fonts on there, and we haven't got a standard by which they can download the Ethiopian fonts onto the phone. Or maybe they've got the fonts and they've got to a social networking website, and it just doesn't work the way their village social networking works. So actually, they have to make their own social networking site, even though the village has got its powers from a water wheel, and the only thing they use it for at the moment is the central point for charging their cell phones. Maybe they should have their own web server there, and they should do their own programming. People are incredibly, when people have very little in the way of networking resources, power resources, they get incredibly creative. So this is a very exciting area. But it's more than web science. And so, well, that first web conference, we were thinking about it, we couldn't quite announce, but we were just starting the Web Consortium. So my last slide in the first web conference, in my closing talk, was an unannouncement of the World Wide Web Consortium. Well, now I can make a sort of unannouncement of the World Wide Web Foundation. Some of you have heard about it. We're now in the process of putting together a foundation, the Web Foundation, webfoundation.org. We've got some seed funding, and we have various people, a few people here, Rosemary Leith is on the board, there are various people here you can contact if you're interested in it, and we're interested in addressing more broadly that the web should serve humanity. It's going to be largely volunteers, it's going to be philanthropic funding from foundations, I think it's really important, and it's amazing how going back to the geeks, going back to the people I've worked with, so many of them have been excited about it. In fact, one of the useful pieces of input to the whole process was the DVD that Silvano, who was just made in his journey across the Sahara as a UN, where is he? As a UN volunteer thing. So lots of people. So you find people all over the place who are very excited about getting involved with the foundation. So in all these areas, so in the consortium, in web science, in the foundation, things are all starting. They're urgent. They're new. There's a huge opportunity. In some cases, there are threats we have to worry about. In a lot of cases, it's very much like it is at CERN now. Just as you're trying to get the beam back up, and you're waiting to get your data. It's like it was back then. Back then, for me, I said that the development of the web, the exciting thing was the people. Back then at CERN, the exciting thing was the people. Okay, so the last thing I'd like to say is just for all the people that I knew, all the people I worked with, all my friends, some of whom here, a lot of them, and the overlap of colleagues and friends was very, very strong. It was great. Thank you very much for being around, for supporting me, for being there, for doing cool things, for discussing interesting things over coffee, for laughing about the names I chose for projects, and reviewing them and trying them out in cases. It was amazing then, and I wanted to specifically really come to use this opportunity as a chance to come to CERN and say thank you. Okay.
Once you're on stage. Hello. Okay, I have my microphone back. So we're gonna do another Q&A session. I'm sorry, you're a very busy man today, Tim. We're gonna start with this. Basically, when we knew you agreed to come for the celebration, we wanted to have a way to involve the people who could not attend, and that they could ask you some questions. So we set up a small system where anybody could ask a question and also vote for the questions they liked. And I wanted to relay the top 3 questions to you. So I'm going to read them. The first one is, do you think that the semantic web will ever works how it is designed in the theory? If yes, when do you think it will happen? You see some people from all over the world probably contributing questions. And what is still missing to reach it? So when are we going to have the semantic web, I think?
Well, you know that thing about exponentials? right? I said that the funny thing is, somebody at MIT pointed out the other day that when you have when you put an exponential graph on a linear axis, it seems to go along, and then it seems to turn a corner and turn around. Now, where it turns around is it's an exponential. It's actually just continually. If you put it in a log scale, it goes like this. You can't say when it took off, but depending on what scale you're looking at, if you actually look at a finer scale, what happens to the hockey stick? It just moves along. So if you look at the growth of the web and you look at at tens of the website scale, the hockey stick seems to be back in 1990. And if you look at it on the millions of website scale, the hockey stick is further along. Same with the semantic web. If you look at it on the scale of people who are actually doing stuff, there it is. It's exciting, and in fact, that's perhaps one of the questions which we should, we could have after. If in doubt, we could sort of postpone use some of this question time.
Okay.
Shift everything up and because after this panel's been here, people on this panel are doing stuff with, and there are a lot.
Semantic web. I think we're going to talk about it. I heard a lot of questions.
It is happening right now. What's missing to reach it? To a large extent, the linked open data thing is the semantic web taking off. There's a lot more which will happen, but anyway.
The second question: if you could travel back in time, would you do something differently?
Okay, so I've said that I take off the double slash. But if I really was going to go back and change the URL, in fact, I've been inclined. First of all, it's most significant. Most of its most significant bit first, apart from the CERN.ch. So I turn that around, so it would be ch CERN. And then, in fact, it's supposed to be a space of names, and the fact that there's a difference between dots and slashes is actually a problem. It's a design flaw. So in fact, it should be http://ch/CERN/CERNland.
It's very European, actually. It's like dates. We start with days in Europe, we end with years. And in the US, you start with years, and you start with the biggest units.
I always use astronomical dates. I always start with the most significant. It's 20090313, okay? I'll have you chanting that. Just YYYMMDD, okay? That's the only logical way to do it. Just give those other things, okay? With W3C standard, if you're going to transmit it over the wire, more significant byte, but consistent. Yes, the Americans are inconsistent about it, and the Europeans, it's inconsistent as well. So
it would sound very weird. I think it would be like com.org.wikipedia.
No, but now if it would be, but ch/CERN people would have become the meme.
Definitely.
Okay, and what would happen is your software would actually look in the domain name service to find a www.legoland, whatever it is, CERNland.cern.ch in the DNS, and then would figure out where to chop it, switch from DNS to HTTP. And then we'd have something which could be used, where we could be more free to change the naming system to a different one.
Okay.
And I think also the whole use of the domain name system was really valuable to be able to use, to jump on. So all you have to do is get a domain name. But nowadays, there's so much politics in the domain name. It would have been interesting to look at systems which didn't involve domain names.
The last question is, how did you get the ID for the World Wide Web?
Read the book.
Okay, that's a short answer.
It was obvious.
That's great. So we're going to take questions from the floor. I said I would go to the left of the room. Do we have questions on the left? We don't have questions on the left. I'm going to go to this gentleman and then behind. Sir, can you just introduce yourself?
I'm Shoptay Gold. I'm a journalist, actually.
Can you maybe stand
sorry, I'm a journalist. I just wanted to get your opinion on where you feel privacy on the web is going, because everything is open and everything is available, which is great, but on the other hand, it means that everything's open and everything's available. And when you design the web, I imagine, I don't know, maybe you did have in mind that people would be using their credit cards and be sharing all sorts of personal data, but that's the way it is now. And how do you see that sort of working, that at the same time we all retain our rights, but everything will be available on the web? Thank you.
Of course, everything's not available. When you log on as a particular person, you get access to particular things. But it starts to get complicated when, for example, you get access to some information as in your role. For example, you have information that actually you've got because you're a friend of somebody, so that on the social networking site you've got access to their photos, and your machine hasn't reminded you of that when you have enclosed them in a website you're making for somebody else. So the thing that we have to address is that some different information is designed to be used for different things. There are different licenses on it, but also people people may want to be able to, for example, make photograph albums out of their photos, to be able to plot their trail across the United States of America with a GPS on the map, but they don't want a prospective employer to use it to analyze where they went on vacation, to see whether they stopped at too many bars, to see whether they drove more than the speed limit, and so on. So to be able to release data and say, I'm only authorizing you to use it for that. If you want to use it for something different, then you're not authorized to have it, I think is an interesting social change, and we can make technology which supports social changes like that. So technologies which are coming, I think, will include systems which are aware of the appropriate use of data. And we're starting to design some terms for describing those, inventing some particular terms and ontologies which allow you to create new types of data use, so that you can put data up there. But as the data is moved around, the appropriate use is tagged along with it, and things are done socially and appropriately.
Another question.
Simon Bradley, Swissinfo. You hinted at the threats which we should worry about. What are those? You didn't really talk about.
Well, of course, everybody's got their pet set of threats. I think if I could lump together quite a lot of the current threats are, in fact, more at the internet infrastructure level. When I built the web on top of the internet, I could write a program which would run on the server and program run on the client. Originally, they were the same machine, but basically, in principle, they're different machines. And across the internet, what happens in the internet, they didn't have to worry about. The internet is a cloud. And the great thing about it, it's always represented as a cloud. People talked about the internet cloud. And so the nice thing was that you just connect to the other machine, and what you put in would eventually come out. Or it wouldn't, on a bad day, but generally it would come out. But when it came out, it would come out unmolested. It would come out it wouldn't be snooped on. So the fact that when information travels across the internet, it isn't molested, it isn't filtered, it isn't snooped on is really important. And obviously, there are governments and there are corporations who would like to, for different reasons, interfere with the websites you can go to, interfere with the data coming back so they put their own ads on top of the ones that were originally put there. They like to snoop to see what you're doing, because if they look at what you do on the web nowadays, they get a fantastically good view of who you are. If somebody can intercept the internet traffic, and just over the last year or two, it's got to the point where you can build, processes are big enough that you can actually build a system which does what's called deep packet inspection and peers inside what's all the traffic to and from your house, and ends up building an incredibly detailed profile of who you are and what you do, and your likes and loves and fears. And that sort of snooping, I think, is really important to avoid. It's really important to keep the internet as something which is this blank piece of paper. Keep the web as something that you can use without thinking that when you click on this, somebody out there, a third party, will know that you've looked up cancer, will know that you've looked up what a gay lesbian website. So no interference with the internet, no snooping on the internet.
So privacy and net neutrality, right? That's the two important things. Gentlemen.
Hi, Tim. My name is Pierre Charru. I work at CERN. I want to ask you a question not very much related to the World Wide Web, but more on the internet. I see now it's very easy to download a film, to download music, to download everything. Aren't you afraid that with the expansion of the web and the expansion of the people having a computer at home, that the internet will collapse, that nobody will be able to transport normal data because everybody is loading the last movie or the last DVD or anything?
Well, for one point, internet service providers are getting quite good at making sure that if they are looking inside the packets to see that to be able to distinguish a video stream from a chat, real-time chat, say, so that if you've got 6 people in the house watching high definition television and you're chatting, the people who are watching TV should lose a frame before you lose your conversation. I think there's some reasonable rules like that, so that the people who are really using a lot of bandwidth should can have lower priority. So to some extent, that you can that can protect the things that which are not abusing it, as it were. But on the other hand, video, the bandwidth is getting pretty high, and so ISPs are starting to get to the point where they are starting, they will be able to guarantee that you can watch a movie. And somebody in your house can watch a movie, and that's how you can spend. And you can start doing that instead of going down and renting the DVD. And people are starting to accept that in parts of the developed world. Yeah, I think it's an issue, but in a way, it's a success phenomenon. And if we get, I think it'd be great if we got internet connectivity across the world, which doesn't give you high-density television, but does get you everything else. It gets you, maybe gets you sound, it gets you, and all the chat and still images. I think that's a very rich world that we've got, even without the video.
We have someone who's going to speak about the future of TV, I believe, in the next panel. We have a final question here. Can you please?
Stephen Pemberton. As you pointed out today, your original web anticipated a lot of things that the web had to rediscover, like style sheets and the read-write web. I wondered if you'd anticipated client-side computing, what we would now call scripting.
Well, there was I think in a very early explanation about how to set the MIME types for different. The example was something like application/C shell for sending down a CSH file. And there was a little comment which said, by the way, you probably don't want to do this because you don't want to run arbitrary scripts on your machine. So there was an idea of people basically would move down anything which you could put on the machine, and the next this gadget there was a mapping from a MIME type to extension on the machine. It would always, by the way, make sure that if it stored a file, it would use the appropriate extension. It would refuse to let you save the file as something different, so that it would never be. But on the other hand, if you've told it that this is a shell program, and this MIME type corresponds to shell programs, and you've clicked on a link to a shell program, it would download it and do an open on it, which would involve running it. So I think people just people laughed about the idea of allowing that. There weren't, obviously, there wasn't the sandbox of the browser. But I don't know when the first browser. Well, I guess it was when Netscape put together the early, what did they call it before JavaScript? Viola is a really interesting case because, yes, Pei Wei, he had already designed Viola was a scripting language. And I am talking to the gentleman behind you. Okay. Sorry. And he wrote his browser in. He wrote his www browser in Viola, so it was called Viola www, not because Viola was the name of the browser, Viola was the name of the language. And so he had in fact a very sophisticated system where you could do very nice animations and make sort of hypercard-like things in the Viola scripting language. And he didn't really push it very, very hard. If he had put more energy into that, I think it could have been a really interesting direction. It could have, Viola could have gone towards being a standard language, and we could have ended up with that. That was all pre-Java. Even.
So, thank you very much for answering the questions. We're now going to start the panel about the future of the web. You staying with us, Tim? You can still talk. Maybe I give you 2 minutes to drink a bit of water. I'm going to call now on stage Chris Beiser. Sorry, I said it in French, so I said something in French. Tom Scott, Dan Brickley, and Stefan Boyer. If you guys could join Tim on stage, please. And so they're going to, basically the idea, when we discussed the format of the event with Tim, we thought we'd do something about the past and we do something about the future. And Tim was asked to pick some people who represent some of the future initiatives that will happen on the web. Each of them will do a short introduction explaining you what they are working on. Maybe, Tim, if I can ask you to explain in one sentence, very, very shortly, I'm going to introduce them in more detail, but what each of these guys is doing, really in one sentence.
So I suppose these three are involved with linked data. Dan Brickley was the chair of the early interest group, and he actually generated a whole interest community around the early growth of the semantic web, and has worked in various different ways. One of the things he did was he was the co-instigator of the friend of a friend open social networking stuff. These people putting link data on in Berlin, the DBpedia data, and here the BBC data. So these guys are all to basically show you that this, just to emphasize that there's stuff happening. It's simple, it's grassroots, and it's exciting, and you should be doing it at CERN. Stefan is going to cover everything else. He's going to cover mobile networking and the foundation and webbing developing countries and things like that. I gather, so perhaps a bit of a line between those. There are lots and lots of areas we didn't cover. We just picked a few, just to give you a sample.
Okay. So our first speaker who's going to tell us what he's doing is a professor at Freie Universität Berlin, so I also spoke some German. He works on the semantic web technologies. He's the founder of DBpedia, which is a database system that allows you to query Wikipedia like a database. He's the initiator of the Linking Open Data Community Project. Please welcome Chris Beiser.
And that's another slide.
I will handle that if you can. Maybe it's the next processor running. Oh, here we are, yeah. Sorry.
Yeah, hello everybody. I'm using my 5 minutes to give a short overview. I'm going to use my 5 minutes to give a short overview about the Linking Open Data project that Tim already mentioned in his talk. So the basic idea of this project is a grassroots effort to extend the web with the data commons by publishing open license datasets, so datasets that are already available under open licenses on the web as linked data. So what people which participate in this effort basically do, they take data sets, they put them out on the web as RDF, and they set data links between records in different databases. So what you are doing on the classic web is to set links between documents. Here people are now setting links between basically records in different databases. So the Linking Open Data project started in May 2007, which is a relatively small amount of data sources. So there's this DBpedia, which contains some data that has been extracted from Wikipedia. There's GeoNames, which describes locations. And there's a FOAF network about which Dan is going to talk a bit later. Altogether at this time, there were around 500 million facts on this, so data pieces on this network, and there were 120,000 connections between different databases, so data links between the databases. Quickly, more and more people started to like this idea, and the network started to grow. So other people published their data sets and started to set links to data sets that were already in the cloud. This continued, and the cloud currently looks like this. So a lot of more data sets, and altogether it's now around 4.5 billion pieces of information in the cloud. And there are 180 million data links connecting records in different databases. When we look at the topics of this data, there's lots of data related to publications, there's lots of data related to people's online activities, there's lots of data related to music, and Tom will also talk about this in more detail in a minute. There's data about geographic locations. There are general data sets that span different domains like DBpedia, WordNet, or a version of OpenPsych. And at the bottom of the graphics, there are lots of data sets that relate to life sciences. As all these data sets are connected by links, as they are all part of a single information space, we can use generic data browsers to explore this information space. Like here we see an example of one of these browsers, Tabulator, implemented by Tim in 2007. This was the first of these data browsers. Here's an example of another data browser which combines information from different databases. So here we see information about Tim from, the provenance of information is shown by the dots. So it's about 14 databases claim that he's a person. 4 databases claim that his nickname is Tim Biel. As all these databases are connected by links, we can build search engines that crawl the complete data space and offer query capabilities over the data space. This is an example of such a search engine, Falcon S, and I just entered CERN as search term, and it did find 571 records in different databases about CERN. As we are publishing data and not documents anymore, we can of course render the data in any way we want. Like here's an example of a mobile application which puts locations on a map and allows you from this map to explore the web of data. Linked data is of course not the only technology that's currently used to publish data on the web. Like most big web data providers like Yahoo, Google, Amazon, they all provide access to their databases through so-called web APIs. The only problem with these web APIs is that they don't allow you to set links between data objects in different databases. So what you have to do as an application programmer is to select some of these data sources and implement your application against these data sources. When a new interesting data source shows up, you have to change your application. What you can't do is to implement applications against all data that's available on the web. So these APIs kind of slice the web into different data silos. And this is also what I think is interesting about linked data. By applying the concept of a link to records in databases, we basically get all this data into a single information space again, and can write applications against this single information space. So applications can automatically take advantage of new data sources that show up on the web. And that's it.
Thank you. Chris Weiser, thank you very much. Our next speaker, take your microphone with you, please. He's a digital editor at the BBC. He's developing BBC Earth, which is an effort to bring the BBC's natural history content online. He's interested in how to design and build the web for everyone to use. Please welcome Mr. Tom Scott. We have to insert some technical failures so you get the conference feeling.
Is that better? That's better.
It's not credible if there are no failures.
Technical glitches. One of the most advanced places in the world, and the microphones don't work. Slightly different take on the web. Stephen Fry recently noted that our challenge really shouldn't be to make humans more computer literate. And really what we should be doing is we should be trying to make computers a lot more human literate, more sort of human shaped, and that's sort of a bit fuzzy. And I think if we think back over the last 20 years, most people would agree that we've made enormous progress towards that objective. Information and computing more generally has become democratized in a way that we've never seen before. Unfortunately, I'm on the panel talking about the future of the web, so I guess the question really is what's happening next? What's the next 20 years about? Unfortunately, I haven't a clue. But what I will do is I'll steal an idea from the science fiction writer William Gibson and suggest that actually the future's here. It's just that it's not yet evenly distributed. I work for the BBC, and it's very big. It's a big place, it's a big organisation, and we also produce an awful lot of content. It's an incredibly diverse range of content that we produce and a very large volume of it. And so I'll propose to you that actually what the BBC represents in some ways is a microcosm of the rest of the web. It would have been probably impractical to ever try to set up a central design and build function within the BBC, much as it would have been impossible to do so on the rest of the web. It wouldn't have worked from a user experience point of view, but probably more importantly, it would never work from a coordination and a governance point of view. I think if you just try to sit down and gather all the requirements and build a sort of left-hand styly website, you'd have gone mad. And as a result, the BBC has historically created a series of sort of microsites, much like this Radio 4 website celebrating the launch of the Large Hadron Collider. And that's great, and what it means is that within these microsites, you get a coherent experience. You can navigate around that information, and that's wonderful. Unfortunately, what you can't do is you can't follow on from there. You can't follow your nose to the next piece of information that you want to find. You can't, for example, find out everything the BBC knows about Brian Cox, if you want to. But it's nothing personal about Brian Cox, because you can't do this for any other piece of content either. We can't find everything the BBC knows about lions or any other species. And possibly even worse, we can't find out everything the BBC knows about one of our presenters, like Jeremy Clarkson. But I'd like to think that things are starting to change. It's been my great honour to work with some very talented people within the BBC to take a different approach to designing websites. Rather than starting with pages or, heaven forbid, Photoshop documents, we started with the data. Actually, that's not quite true. What we really started with was trying to think about the things and concepts that matter to people. Forget about web pages. What matters to you? What matters to the people? And each of those things, we gave them a URI. Because once we thought we could identify them, then we can do stuff with them. And the three projects that I wanted just to touch on briefly, BBC Programmes, which is bbc.co.uk/programmes, although actually if you ever end up on that homepage, you're probably lost, because what it's really trying to do is it's trying to provide a web presence for every programme the BBC broadcasts, on TV, on radio. And once you have that URI, then you can then dereference that identifier appropriate to your device and get that document back. That might be an HTML document for your desktop browser. It might also be a piece of RDF, it might be JSON, it might be a mobile view. On a similar vein, we are building a new music site, which is, at the heart of that, is Music Brains, which Robert Kay, who's in the audience, is responsible for. And the new music site, in a similar vein to Programmes, which is giving a page per programme, tries to give a page per artist. Every artist the BBC plays now has a URI. And that's quite cool, because when we stitch that into with the programme space, you can now start to go on a journey from an episode that played an artist to that artist, find out other programmes that have also played that artist. And the idea being, obviously, that we're introducing people to new programmes and new music they might find interesting. Because they're separately addressable URIs, you can do the same thing for data. It doesn't have to be done on the web browser. And the final one, which is my current project, which is a project called BBC Earth, which is trying to do the same trick for natural history content. We're trying to make a page for every concept within the natural history domain, so a page per species, page per habitat, a page per adaptation, behaviour, what have you. And of course, as with programmes of music, the website is the API. There's no sort of separate other thing that you have to go to. Each URI can be dereferenced to return RDF, JSON, a mobile view, an HTML desktop view. Now, obviously what I'm talking about here is linked data, which Chris has mentioned. But the slightly dirty secret is when we started, it wasn't linked data. We didn't really realise that that's what we were doing. We just knew that what we wanted to do is we cared deeply about URIs. We wanted to make sure that everything had an identifier for every concept and thing that mattered to people, and that those things could be represented both for machines and for people. And we did that because we thought that it was the only way that we could break out of that sort of microsite development approach and build sane, coherent, scalable websites across the sort of volume of content that the BBC is producing. And I think that as a result of that, what we've done is we've started to produce something that's a little bit more human literate, a little bit more human shaped, and a little bit less web document shaped. And so really what the Semantic Web Project has started to help the BBC do is it started to help move us away from this idea of web pages and starting to move towards the idea of concepts and things and data. So the idea being that eventually you will be able to find all things Brian Cox, all things Lion, or all things Jeremy Clarkson. So my hope is, or my belief, I suppose, is that the future of the web is human literate. I think that the way of achieving that is by following the principles of linked open data. In other words, HTTP URIs for the concepts and things that matter to people, and that those things are linked to other things that are related to them, all dereferenceable to the appropriate document for your device at the right time. And I say it's my hope, because it's certainly been my experience at the BBC, that it's the only approach that I found, certainly, that scales to build coherent, usable, human-literate web services. Thank you.
Thank you very much, Tom. You can take it with you. I have another one. You should really research more, try to get more info about Brian Cox. He's actually a former pop star who became a nuclear scientist. And he's lucky to be called Brian Cox because the compromising YouTube videos are very hard to find, thanks to his name. Our next speaker helped create various semantic web standards while working at W3C. He's now back to academia, As a researcher at VU University Amsterdam, he created the Friend of a Friend project, also called FOAF, with Libby Miller, and he's now working on NoTube, a future of television project. Please welcome Dan Brickley.
Hi there. So this is a very special occasion, and we've heard a lot today about Tim Berners-Lee, inventor of the web, and I wanted to try and introduce the Friend of a Friend project by paying tribute to Tim Berners-Lee, graphic designer. So I've shamelessly stolen most of my graphics from Tim, from his original 1989 memo, and from a talk he gave here in 1994, just as the web was starting to go crazy. So the suggestion here is that the web of data, the things you've heard about from the previous two speakers, has really been in the web plan from the start. If you look at the document Tim wrote 20 years ago, it's all in there. So to understand the future of the web, really look to its origins. So what I wanted to do was pick on this phrase, vague but exciting. And it is vague but exciting. If you look at the diagram in the 1989 document, it's got all this hypertexty stuff, links between things. But if you look closely, they're kind of rather different kinds of links. Some of them are links between documents, and we know all about that now. There's trillions of the things. A document refers to another document. But also up there, he's got links between people and documents. Tim wrote this document. This document describes something or other. You know, describes lions, describes TV stars. And the vagueness was explaining what exactly is going on there. Some are hypertext links, but some are facts or claims about the world. And I think right there on the first page of this memo, you've got the roadmap for all this work we've done on linked data, on FOAF, and on semantic web. So moving into the other graphic I stole. Where are we? The Semantic Web Project really, I think, it's about unraveling that mystery of how we relate links between documents to links between people, links between the stuff, as Tom says, the stuff that we really care about. People don't care so much about documents. They care about their real life. And this diagram here is probably my favorite Tim Berners-Lee graphic. I stole it from the 94 presentation. And I was not involved in 94. I was at university or something. But the explanation I saw of this on the web was in terms of the web shadowing reality. To computers, the web was flat and boring. It was links between documents. And to us, the world was the thing of interest. It's links between people, types of things. I mean, it's illustrated here with a little yellow house, some people, some T-shirts. Off to the right, there's a light bulb. it's charming in its childish simplicity when you realize, you know, there are, 6 billion people now, 106 if you count the ones that lived previously. There are trillions of documents. But this diagram, I think, captures the essence of what we're trying to do. We're trying to build a web that shadows aspects of reality. And we build a web of data if we allow documents to describe these things and relationships. So you see down there Tim's original diagram. The mystery is kind of unfolded a bit if you think of each document making claims about that world that's up there. And we need arbitrary relationships. We need relationships that come from user studies at the BBC, that come from people building applications. We don't need relationships that are anticipated by 2 or 3 computer programmers. And that, I think, is the core of the challenge in front of us. So web pages make claims about the world. Increasingly, they're in data forms that machines understand to some extent, as well as people. And the claims about the world, they might not always agree. So in Chris's picture of Tim, you had information about provenance, where facts came from. That Tim was a person according to these 15 different databases. That's absolutely critical to what we're trying to do here. That when we're lucky, the documents agree, the claims are consistent, and we can build a big database from all this stuff. And when the documents disagree, at least the disagreement is mechanically evident. We can put it into Excel and do analytics over it. So how does this connect to FOAF? The Friend of a Friend project was really an attempt to put some of these ideas into practice. We had technology, RDF, which was done in, I think, 97, 98, 99. And in 2000, you know, I wanted to see it actually used. And I was collaborating with Libby Miller, sat down here somewhere, Damien Steer and others in this room. And we started just writing machine-readable documents about ourselves. So the first FOAF file was my homepage, turned into machine-readable data. The second was Libby's. And it just rolled out from there. We had 2, 3 friends of our friends, eventually hundreds, thousands, millions of these files. And what was fascinating to me was the extensions people made. We had blood type extensions. People wanted to describe in Japan their blood type, so they did. They put that in there. We had family tree stuff, language skills. I could say, you know, I speak Spanish very poorly, or I'm learning Croatian. You could describe software. One of the original use cases from Tim's document is, you know, who maintains this software? What does it depend on? Where did it come from? Which group? So Ed Dumble came up with this description of a project language for describing software. And it all mixes into the same data environment. Each new linked data set that you saw in that graph enriches the whole network. Each new data set about music increases my ability to describe myself and my musical tastes. You know, we waited for the music brain stuff to come online in RDF so that we could describe people's music preferences. If I want to describe agricultural research, which is what not many people do, but lots of them, the UN FAO are putting up their data from the Agravoc thesaurus that describes in great detail that very scientific world. It's another blob on the diagram. Every month there's another few blobs. So FOAF is, in its own way, a tiny little boring project because there's not much in there. But every FOAF description can take from it the bits it needs from the rest of the web. Last thing I wanted to say was that in the last year we've seen Google with the Social Graph API, Yahoo with SearchMonkey and their boss, customizable search engine. In Russia we've seen Yandex, which is the big search engine there. Things from the semantic web community like Syndiche and Falcon, putting up big databases of this stuff. Also Garlic have their QDOS product. Once you've harvested all this stuff from the web, you can ask it questions you can't ask of a single document. Questions about, you know, here's a claim, which other documents agree with it? Who wrote those documents? Where do they come from? So it's really exciting times. And I just want to end by saying, if you want to understand where it's going, go back to the beginning. Read the document that's 20 years old. I think probably less than half the people in this room have read it from beginning to end. And it's really worth reading. It's not some mystical tract of sacred truth, but it's got a lot of clever ideas in there. Ideas which 20 years later are only starting to roll out on the web. So think of the web not as a thing, a static given thing, but as a project that's only just getting going. Thanks.
Thank you, Dan. So then wanted to ask you guys, how many of you actually read the original proposal? Hey, quite a large number of people.
So you have homework.
How many understood it? How many wrote it? So before we go for the discussion, we have one final speaker. He's been a W3C staff for 14 years. He's the head of Web in Society at the WWW Foundation. Definitely a hard name to say. And he's the chair of the W3C Mobile Web for Social Development Group. Please welcome Stéphane Boyera.
Thank you very much and good afternoon. So in a few minutes I want to say a few words about the World Wide Web Foundation. So Tim mentioned that briefly. So he founded the foundation last year and announced it in September. And now we are starting to develop its plan. So one of the major objectives with this foundation is to extend the benefit of the web to all people of the planet. Today, there are between 20 and 25% of the people who are connected on the web. And there are more than 5 billion of people who are out of the picture. And among these 5 billion of people, a big part are living below the poverty line and are earning only a few dollars a day. So the big question is, can the web be useful for them? And above all, can the web improve their life and impact them positively? Obviously, if we are starting this foundation, and if I'm here, we believe that the answer is potentially yes. The web has clearly the potential to overcome the lack of infrastructure that's suffering developing economies. So for instance, the web could be a solution to provide education content and teacher where there is no school. Could be a way to provide access to banking and microcredits where there is no bank, or access to doctor and advisors where there is no hospital. So mostly there is a big potential for the web to be a solution to provide life-critical information and services to people. Of course, there is a second big opportunity, and also Tim mentioned it, which is the 4 billion of mobile phones which are in the field today. So 4 billion of people have a minimum computing power in their hands and a minimal connectivity. So this basic layer is a great opportunity, particularly in developing countries. So the big challenge here in this area is to see how can we take advantage of this minimal connectivity and have many socially oriented services appearing on the web and helping people. So the challenge is really to lower the barrier for people to develop, deploy, and access those services. In my view, we are in a situation which is quite close to what was the web in the 90s. There are technical gaps, particularly accessibility issues. Few examples: how can we make content today that are accessible for people who are illiterate or who have low reading skill? This is something that developing economies, and particularly underprivileged population and rural areas, are suffering. How can we have content delivered in local languages? That's a key point to access those services. But there are so many languages that are not existing on the web today, because either there is no character set, or because they are not renderable, and so on. So that's about internationalization. There are also, and that has been mentioned previously, there are also this issue of computer literacy. How can we help people finding content and services, searching the web when they have no previous experience? So there are lots of kind of technical issues that need to be solved to have the web really be relevant, usable, and useful for people in developing countries. So that's for the access. There is a second big point, which is about authoring. There are millions of NGOs and grassroots in Africa, in Southeast Asia, in South America, that are really eager to have new tools to help more their community, their village, or their country. There are potentially millions of potential social entrepreneurs that would be happy to create services that will help their community and at the same time create jobs for them. So, so how can we empower all these potential contributors and help them authoring and deploying services? There are three major points. Raising awareness. There are still lots of people that believe that mobile phone is a closed world, and it's as difficult to create a mobile services as getting a slot on a TV channel. So we have to raise awareness. We also have to build capacities, train or make training available to all these potential contributors so that they get the expertise to develop their services. And then, of course, support their actions through availability of open source and free tools. So those are just a set of potential actions, of really barriers that are existing today for the web to be really a tool that could impact the development challenges in the world. As I said, we are just starting, we are just building up the strategy for the foundation. We are expecting to announce a set of initiatives during the course of 2009, and our objective with this new foundation is to really have an impact in this domain. Thank you very much.
Thank you. Thank you very much, Stéphane. I heard once that I think 60% of the traffic of BBC Mobile comes from Africa. You correct me if I'm wrong. I think I heard that from a Kenyan speaker we had this year, and it shows that Africa is actually connecting and joining the online, but in a different way. And big companies are actually noticing. Nokia is working on developing a phone for the illiterates, for example. We have a few minutes for discussion. We are standing between 300 people and the cocktail, so it's not an easy situation, but we try to manage that. Do we have some questions in the room? Yes. So we're going to take a couple of questions. First, while the microphone gets there, I want to ask you, you showed some technologies, right? And these technologies are going to be leveraged into applications. And I'm going to ask the question of this gentleman at the beginning and wanting to know a bit about the future. But can you tell us some examples of future applications we can concretely expect as users? I mean, leveraging all the things that you guys are doing.
Maybe to cut it short, move from a search engine to an answer engine. Because currently, search engines help us to find documents, but actually I don't want to find documents, I want answers to my questions. And as the web is continuing to develop into a database, I think it becomes possible to build these answer machines. And I think this would be a nice application.
Who wants to add something? Potential applications where your technologies could be used?
So sometimes people talk as if we'll be flying through data in 3D wearing sensory suits. And I would be happy if we never see this stuff, if it just gives us slightly better search results, if it means my mailbox has automatically created folders, if it means things work just slightly better.
And in a more open way, right? Because the standards you're pushing is not a closed world like some big, giant social networking I'm not allowed to mention.
Yeah, for data to flow between systems so you rekey it less frequently, for example.
Stéphane, all these mobile technologies? I heard, for example, in Africa now there are some banking systems via SMS, for example. This is pretty amazing stuff happening through the mobile.
Yeah, so exactly. We are in a situation now that I call proof of concept. So there are already an incredible sets of success stories that demonstrate the power of very simple service that really improve people's life. Just few examples. Very well-known one. Fisherman community in India, they are able to query market price when they are coming back from the sea, and depending of the catch they have, they know to which market they should bring their fishes. Studies has demonstrated that this system increased the income of the people by 8%. So just using this simple SMS service, they type in the name of the catch, and then they get the price around them. It improved their income by 8%, and it decreased the price for the buyer by 4%. That is, the price of people buying fish decreased by 4% because there were no more waste. So if you go to a market where there is too much fishes, they are lost and they are just wasted. So now with far less wasted, the price is better for the fisherman, the price is better for the user. So that's just one example. Another one which is very, very important, also is just in Bangladesh. When you get a baby, if you don't register it to the state, it doesn't exist for all his life. That means he cannot access to education, he cannot go out of the country and all these things. There are now systems that people can register their child through mobile phone, and that's completely changed the life of the child, starting as the first day of his life.
So the first thing you teach your child is how to send an SMS.
The father.
The father. We had a question here. Can you please stand up and introduce yourself?
Yeah, George James. We've seen that the current linked data constitutes about 4.5 billion records. And my question is really about scalability. Do you anticipate that the traditional sort of relational databases are going to be able to scale to cope with a massive linked data environment? This is just the tip of the iceberg. Or are we going to see more of the sort of schema-less scalable databases like Bigtable and SimpleDB and MDB and those kind of things? What's your view on the way this is going to scale up?
Well, okay, my take on this is that when you look at the web, you find that it's got this interesting scale-free property. So it means that you've got, basically, if you can think of a sort of shape of information out there, it's out there. So I expect the data out there to be of very, very many different shapes. So there's some data is naturally very square. It's tabular. Weather data from balloons, they all send back the same set of sort of 5 readings every one. Masses of that data, and then people summarize it. Other data, maybe if you take stuff from a physics experiment, there's a block of data, but hanging on the side of it is the fact that actually this piece was taken from this, while this valve was in this position, and this valve actually connected to these 2 pieces of wire, and this piece of pipe, and this piece of pipe was put in by this person who was on vacation. The connection, when you start going through all the connections that you actually have about all the data, which then you find some parts of it will be very blocky and best handled by relational databases. Others will be best handled by column stores. Others will be handled by triple stores. Some of those triple stores will be indexed only on the predicate, and some of them will be indexed on the subject and the object, so that you've got. So I think that there's going to be a need for all kinds of different systems for doing sort of the local applications. But then when you take it and go global, and you ask this, Chris said, turn it into an answer machine. Supposing you have a machine which just takes an arbitrary question, like, what's the average age of all the CERN electricians who installed light bulbs in the southwest tunnel of the whatever? Okay, during a time that the power level was at during a time that there was enough snow to ski at Val d'Ivier. Okay, so then when you start asking questions like that, you're connecting things. They may be silly questions. Sometimes they will be inspired questions. And so then you're connecting things of all very different angles. And then I think there's a lot of research needed as to how do you optimize for when somebody's asked a question which is joining these very differently shaped things. And so I think that's some open research. Chris.
No, finish.
I think Chris wants you to. You can finish your sentence. He just was trying to grab a microphone to follow up on what you were saying.
No, I'm finished.
Okay.
It happens.
Chris, you wanted to add something?
Only very small comment on scalability. Google is currently building its computing centers and the intersection of high power lines and rivers. So handling this data will require some sophisticated equipment, but I think it's possible.
And it's a very interesting topic, actually, scalability and overload. Now that the web is here, we all think that we're going to be overloaded with data. And actually, my colleague Nicola Nova found a note from 1614 of somebody saying, now that we are printing books, we're going to be overloaded and it's going to be the end of the world. So it's kind of a relative notion, and we always end up finding a way to cope with the increasing amount of data.
But
we have a question. Sorry.
If you're from a community which actually has thought about the problems of scale of large, huge quantities of data, then if you find anybody who's thought about that, then let us know. They should join the semantic web community and start to. I bet some database engineers and people pipe this.
You're welcome to join if you want to help. We have a question in the back of the room.
Hi, my name's Tracy Logan. I'm from the BBC Digital Planet programme. It's really a question about the transforming nature of technology on our ordinary human lives and the power of the semantic web in the future. Back in '94, Nicholas Negroponte told me that he thought that digital communications technologies and the World Wide Web was going to make us more asynchronous. And I didn't really understand it at the time, but now we have podcasts, we text, we don't talk direct, face-to-face. So I was just wondering if there's a way in which you think the semantic web is going to change our lives in a kind of more philosophical sense.
Yes. I think so.
It's a tough question. So
I think that the frustration that we didn't know we have with some of these technologies, so the web was an answer to a frustration nobody knew they had. They may have been cursed and sworn, but they didn't sort of see what the jump was to me. But now the semantic web is, in a way, it's a solution to a frustration you don't realize you have when you look at your calendar. And there in the calendar, as it says, you're going to go to a concert. And you aren't immediately in the music system, looking at the tracks that you've got. You can't immediately listen to the music or find out the details of the person who's singing in the concert. Now, there are mashups people are building on top of the linked data where you do that, but it's not connected to it's not yet connected into the typical calendar. Calendars have people in them and they have places, and we're still desktop software is really sort of very primitive when it comes to the business of going straight from the event to the person involved in the event. And it certainly hasn't thought about going to the music that person sings, even though that might be the most important aspect of them for that event. So I think if you need a little simple thing, more connected, or your life is already connected, but your computer doesn't understand that. Life will get easier when your computer gets it. When it knows that you're in the middle of this event at CERN, it should know where you're supposed to be. And if you're not there, your GPS should have a little arrow pointing which way you should walk in order to get to the globe, because that's all stuff your computer knows already. So that the connection when your life is connected, when the web understands that connection, then life should get easier. Denbury, did you want to?
Yeah, I wanted to talk about, is this? Okay. Social networking sites. At the moment, there's a kind of geographic cluster effect you get with social networking sites, which rather unfortunately separates populations from talking to each other. These sites are not technically integrated, so people from one site can't make friends easily from people on another site. Orkut, for example, was huge in Brazil. Orkut was, for a while, huge in Iran. Friendster, I think, is big in the Philippines. Bebo in Ireland, and so on. We have a group starting at W3C on social web interoperability, and I think one of the reasons that's important is that children in the future will grow up with friends in other countries which at the moment they only hear about on television, they only hear about in the tabloids, and that's something I think all technologists working in that field should bear in mind.
Yeah, just one other point on that is that if you think of what we've done with the web historically, we've mainly been about broadcast, we've mainly been about publishing things, and people haven't really figured on the web yet. And actually, even if you think of the social networking sites, they're not really on the web. They're there's an expression on the web, but they're not part of it. And I think that what's interesting about some of the diagrams we saw earlier is that I think the way we're going is we're going to have people being identified, so a URI for a person. And I think that technologies like OpenID, where you can assert ownership over that URI, allow people to be identified on the web, and that creates some sort of quite interesting opportunities, because it means that I can connect with other people I know, not within a site like Facebook or Bebo or what have you, but actually on the web. And then that social graph and my attention data, so the things that I do on the web, can then more easily connect me to the other things, the other concepts, the other documents that I am interested in or I might be interested in. I don't know whether that's quite philosophical, but I think that it's interesting anyway.
A question here, please.
Yeah, Michael Parmley, U.S. Mission here in Geneva. A question that maybe reflects my ignorance. To what extent is bandwidth a restraint, a restriction on our ability to expand all the connections and the connectivity and ability to search and everything that we've been describing in such an optimistic way today? Do we have to wait for bandwidth to expand?
Yeah, we still live in a very asynchronous world. Download speed is very good, but upload, typically to contribute videos to the web, is really painful. So do you see that change in the future? Do you think it's important for what you do? Is it going to enable new usage, typically?
I think certainly for the idea of this asymmetry, so for a read-write web, getting that asymmetry out, getting it is important. Stephen Pemberton, sitting there, gave a great talk just recently saying everybody should have a web server. Why should you have a web server in your attic or somewhere in the cloud? Well, because all this, when you've put your your details of your curriculum vitae out there for anybody, any job hunting program to find you, then you don't want it to be owned by one particular job site. You want it to be there available, and you want to control it, and you want to control who has access to it, so that you've got to be the master of your data. So you should have virtually or otherwise your own website, and if you're going to actually have your own website, then there's going to be there may be a lot of traffic. So that's a bit of an issue. But we had there was a question about video earlier, which is similar. I think there will be some applications looking at this. The fractal nature of the web is that there will be a few really big things and lots of, there'll be a long tail of small things. So there'll be a few really big websites and a few really big databases. So CERN is kind of special when it comes to large throughputs of data. Not everybody has got what was it? How many was it? Gigabytes, a rather frightening number of...
It's like 7 kilometers of CDs per second or something like that.
Something like that. CDs per second, where SI units have gone places where I cringe. But yes, but huge amounts. So CERN is special. So CERN, there will be pieces of data which, if you want them, you need massive amounts of connectivity. There will be things that you might want to watch, like high-def movies, later on high-def 3D movies, but where you'll be pushing the bounds as a consumer, but there'll be masses and masses of stuff, of uploading photographs, of making phone calls, which really does not stretch it. Because when we build up for video, the video bandwidth you need is so much more than for things like sound and typing and sending email and just interacting on a website. That all that stuff ought to be more or less become carried very, very cheaply.
Stefan?
Sorry? For the same price, bandwidth, Stephen says,
every
every 10 and a half months.
Stefan, you wanted to add something?
Yeah, just a slightly different point. I believe it's really important that we always look at what we can do with what we have today. Particularly in my area, there are lots of people saying, okay, so you are promoting the use of the web technologies on mobile phone, but so we have just for now, we have mobile phone, but we just have GSM, or at best we have GPRS. And people say we should wait for WiMAX or future high bandwidth technologies. There are things we can already do today with very low bandwidth, and we should already start with what we have today and not always wait for what we will have tomorrow. So I think it's really, really important to start with what's possible today with the bandwidth we have.
We're going to take 2 more questions, then we're going to go for drinks, and you can ask these gentlemen your questions at that time. Vlad, in the back.
Hi, so I'm Vlad Schiffer from ETH Zurich and co-founder of the website webofthings.com. And we've talked a lot about people who are being connecting through the web, but I've seen more and more devices that are also being smart fridge or whatever. And I'm really curious about what are the concrete activities from the W3C in this area, because other than Dave Raggett with his concept web of things, I don't see really much of devices and standards pushed by the W3C.
Ubiquitous web.
Internet of Things, ubiquitous computing. Are you guys working on that?
About the web, yeah, using all these.
There's lots of sides of that. So lots, part of it we call ubiquitous web. Actually, that's of course the semantic web is when you this little web of linked data applies very well to sensor networks. So one would imagine, for example, in this linked data web, that you would expect to have your fridge and your central heating system will be down somewhere in a little domestic corner. I haven't seen people connecting those things in yet. Was there a particular area of it you feel that we should be pursuing, which we're not? Which Yeah, I think people, it's happening in various places. You're right. When connecting the semantic web, we perhaps pushed, I think pushing the linked data meme, the idea for semantic web is the most effective thing to do now. It's the most relevant thing. But the idea of it as being data which can be used by machines was something, was an earlier way of phrasing things. And data that can be used by machines obviously means that things, your fridge can go out and find out what the temperature is outside your house by going to a weather site and things like that. So that I think that it's going to.
So the smart fridge will happen after all. I thought it would never happen. Stefan, you wanted to add something?
Yeah, just a small point. So we have a world domain called Ubiquitous Web Domain, which exists for many years. We have been very active, notably on mobile. So we have this huge mobile web initiative we launched in 2004, which was really looking at making web access seamless. And we have had a great success on this. We have Ubiquitous Web Application Working Group. Dave is used to chair and manage. We are moving slowly. We have been also looking at voice technologies, multimodal applications since more than 7 years, I think, or something like that. So for now, really, my own view, because I've been in this domain for about 10 years, the industry is not really ready yet. So we are exploring, but it's more exploratory work than real direct application today. What is the most active domain is clearly web access from mobile, which is also something we are working hardly on it.
There's one area which I think may happen quicker than we imagine, and I hope will connect on directly to the device independence area, and that's ubiquitous screens. The cost of a pixel of screen has been going down very rapidly. I don't have off the top of my head a number for it, but you notice, for example, some places, have you noticed that there is a sort of a little fungal growth down here in the corner? That seems to be somebody left 2 screens together overnight, and it's been cold and damp down there. And those things, because they're getting cheaper and cheaper, they'll spread so that the stuff behind us will be, in the future will rapidly, they're starting to get rooms where it's all over the walls. And so that actually writing code that can take advantage of that, so that you come in, you've been working on your little screen, then you walk into a room like this, and it manages to switch across, I think is something that's important. That's basically device independence, and it's important to remember that device independence isn't just about going down to smaller devices and dumber devices. It's also going to huge 3D screens and very, very powerful computing platforms.
One last question. I know there are more. I'm sorry. We can have further discussion during the cocktail. Sir?
So I'm Filippo Catalano. I have a question on the commercial future of the web, how you see it. We cannot deny that where we are today is also a contribution of the Amazon, of the eBay, of the paid search, also the huge investments in infrastructure that came through a lot of commercial activities coming on the web. All the things you mentioned on linking data and so on and so forth. How do you see commercial applications, commercial future being built on top of that?
I suspect, do you mean without advertising? Do you think, do you mean because a lot of it is advertising funded at the moment? Because I'd noticed that I point out that when you go to Amazon and you buy something, you're not actually using the ads. Well, sometimes you might follow an ad, but you go to Amazon, you search for something, you buy something, and you're doing a transaction. And all across the web, people are using the web for commerce, independent of the ads. There's an area of the web which is a certain amount of the economy, which is web advertising. But that is a small part of the huge economic impact that commerce in general has, that it can use the web. All the catalogs out there, right, they're not advertising, they're not things which are pushed in front of you, they're things you go to look at. Okay, there's huge amounts of all the specifications of parts which you might want to buy for a new accelerator. There, you go out there and find them on the web, and they should be all linked together as data, of course, by the way. So there's a huge amount of data which is put out there, not because it's put there for advertising. So when you look at the stuff, the linked data stuff, what's out there now, the Wikipedia stuff was put there just for people working for the common good because they thought it was important to have. Some of the other data similarly has been put there similar. But you can imagine, but after a while, imagine that when the first seller of, say, cars puts out there an RDF file which has got the specs of each model, the position of each car for sale, the link between which model that car is, okay, and the color of that particular car. So I can then go to those, so then I can go search when I'm looking for a car and find all the red cars which are near Geneva, which have got a capacity, power between this and much and this. And suddenly I'm integrating data across all the people who've put data there. If you haven't put your data there, you've disappeared. Just like when the web came out. If you didn't have a website, suddenly you were trying to sell cars, you didn't have a website, you vanished. The same will happen with data. It's not, commerce will depends on efficient interchange of information. Commerce will run much more efficiently when we're exchanging when linked data, when the specs are out there in linked data, and I think it'll be just like the web, that the successive disclosure of information, that once one person does, it becomes a competitive thing, that you just have to get the data out there, otherwise it's so boring, difficult to deal with you.
Thank you. From the homepage to open data, quite a long way. Thank you very much. I'm going to call Ben, Siegel, Jean-François, Robert. Could you just join us on stage, please? Join this gentleman, so that everybody can give all the speakers of the day a big round of applause. Thank you very much.
Thank you. Hey, thanks for coming out.
Thank you very much for traveling all the way. Don't sit, we're going straight for the cocktail. Thank you very much all for coming. Thank you, Tim, for traveling. Thank you, Ben, for helping me and the other team members set up that event. Thank you very much to the CERN people, James, Gilles, Arnaud Marcelier, the W3C staff. And now it's time for a drink. Thank you very much.
Okay, thank you to CERN for hosting the whole event.